will dive into a highly innovative topic, quantum gate-based model for VRP model and quantum teleportation for secured communication. Our esteemed speaker for the session 3 and 4 is Dr. Kumar Gautam. Dr. Gautam is the founder and president of QRace and the director of eGreen Quanta LLP. He holds a postdoctoral research position at GIST, South Korea, where he focuses on the quantum vehicle routing problem. Dr. Gautam earned his PhD from Delhi University, specializing in quantum gate design based on Schrodinger dynamics. With over 8 experience, Dr. Gautam is proficient in missions QSDE under the Atal Innovation Mission, Niti Aayog, Government of India, where he promotes innovation and entrepreneurship among students. An active member of the academic and professional community, Dr. Gautam is a senior member of IEEE, a fellow of the IETE, an affiliate member of the Royal Society of Chemistry, and a life member of WIBHA. He is also a member of IEEE Consumer Electronics Society's Technical Committee on Quantum Technologies. Dr. Gautam has published numerous research papers in esteemed journals, holds several patents, and has successfully managed various sponsored research projects that have been submitted, approved, or completed. His dedication to advancing quantum technologies and sustainable solution positions him at the forefront of the innovation in his field. Dr. Gautam's expertise in quantum technologies has led to collaborations with leading industry partners and academic institutions. His commitment to mentoring your researchers and students underscores his passion for knowledge, sharing, and development within the scientific community. Before we begin, a quick housekeeping note. Please ensure your microphones remain muted during the session to avoid any disturbances. Feel free to post your questions in the chat box and we will address them during the Q&A session at the end. So without further ado, let us warmly welcome Dr. Kumar Gautam to share his insights and expertise. Over to you, Dr. Kumar Gautam.
Thank you so much. Good evening, everyone. My voice is audible?
Yes, sir.
Yeah. Thank you. And thank you so much, Pavan sir and Rajkumar Goyal in Technical College. It's a really great pleasure to always is when you are supposed to be connected with the quantum technology or talking with the quantum things in particularly. So I'm just sharing my PPT. Is it visible?
Yes, sir.
Yeah. Thank you so much. So today talk is basically I'm more emphasize on a real-time application, particularly as ma'am said about my work and my work profile and somehow is too. So this talk is not exactly just a talk in somehow is too. I am also looking at collaborations and inviting the people and somehow is too specifically for one domain, which is exactly in the maritime industry. This is the one application. Other than that, my second talk is obviously it's talking about the how the teleportation should be like helping out the in quantum communication domain. And we are also planning to like how to set up a quantum channel, particularly for establishing some using the trusted node or gate-based model. This is the basic idea. But before that, we have to just introducing recently our startup is selected by challenges of quantum readiness, which is basically we develop as some quantum optimizer, which is exactly the quantum meteoristic optimizer for the maritime. And the next week I will be meeting the big like in this year is it's a big first crack. is we're meeting with the port industry, particularly for the Goa port, and we'll present my work to Goa port, and hopefully, if everything is well and somehow is to so another project is also accepted, and it's a big opportunity to all the academia and researchers, or somehow is intern people are take it connect with this. Second is, I mean, just today I also discussed with some NQM projects regarding the lab setup and all. So I'm always emphasize to people to if is it possible to come to start a quantum computing lab or any communication lab. Sensing and material is not my area, but some of the particular topic in this talk I will share the my problem statement where you are supposed to be right now talking about this. So this is was exactly on 12 I'm going to present for quantum optimizer for yard side because I visited some ports also, and even when I was in South Korea, I found the many like technological development in the industry in maritime on some other industry also. But in India, obviously, private entity is always like always one step ahead or two step ahead. But the government is now right now they are trying to collaborate with the academia as on industry partner to set up a sub call on the port side or some railway and also. But this is what exactly is I am looking and starting some the yard optimization for meteoristic optimization. So obviously just 2025 is just finished, and this year is basically the post 2025, and it's a quantum is a not like a it's a new buzzing word. It's already the UN has declared that 2025 is 100 year of the quantum science. That means that somebody has started in 1925, particularly the terminology, the buzzing word is the quantum or any of the related to the quantum. So it's a people are talking. It's emerging tech. I said, no, this is not an emerging. Obviously people are somehow recently just 10 year, 5 year before they started working on the quantum and stuffing of the quantum things. But already the many development is in theoretically or some experimentally based did some from the 1925 to till now. Okay, and I'm briefing about to some timeline and story about this particularly. So obviously, I mean, many times I heard this private institute are not somehow did not get any fund and all. So how will start the or collaborate with this international quantum mission or as well as the national quantum mission also. Okay, so see, this is the quantum buzzing is particularly, and if you are supposed to be connect with the or start a research or any work related to see this left side, this is the what exactly the diagram. You can just pick today itself. I can start in the cyber side. I can start with some application based on communication, radar, meteorology, sensing, GPS, anywhere. Like this technology is now somehow is to grabbing entire ecosystem particularly. So if you want to start some talking about the quantum technology, where to apply and how to apply, the first question is always I'm talking about that. So first today on this you have to just pick, okay, my mind is somehow is to pick on the sir underwater. So now the second is how to start. So underwater, what exactly? If somebody has started, no, sir, I am working on the communication side. So one application should be first you have to fix, and then you can start the pursuit through TRL0 ideation stage to validation stage, then validation stage to some prototype, and then you can collaborate with academia. I mean, many startup are working, including like not only the QRace and Green Quanta. Now the India is almost recognized, almost 40 plus startup is there. So you can come and you can connect with the startup people also. They are very hardworking and they're working on some of too, like and measured many development is already there. So coming to the budget side is particularly, I always sharing this diagram is particularly, see this, the till now is totally global effort is somehow is in quantum particularly is 55 billion USD. This is the what exactly. And why I'm supposed to be sharing this number is particularly like, okay, if you are not getting fund from this here, you can just scan it in the entire world, where if any person, collaborator, professor, researcher, or sitting in any of the global place on somehow, so you can approach and somehow to. And my suggestion is to approach to South Korea, some Bavaria, Germany. This is the what exactly. Some Australian government is also just last 2 weeks before they announced the Indo-Australian plannings also. So I mean, talking like a US is very like don't forget about that. Only the US is doing that. Many, I mean, Canada, US, even Saudi side is also many opportunities there funding efforts. Just you find out the collaborative partner and work with this. So lots of number is there, and we can also help to how to start your pursuing and research. as a Modi ji has already said, "Har kaam desh ke naam." This is the one tagline particularly. So obviously the mission is also always talking about that to develop some, I mean, so from the grassroots, I mean, institutional level to industry level also. This is recent. If somebody are interested, this call is recently announced by the ISC Bangalore, and one of the problem statement is what exactly talking to today we are basically. Why I'm sharing this call of proposal is particularly the last date is the 15th. So this is basically the academia industry joint proposal. Anybody can like become a PI and start the pursuing of this to associate with the any industry or startup partner. So one of the problem statement is how to identify this hybrid or quantum based optimizer for logistics side like a rail, Airbus, road or port also. So today I am discussing about how to develop a quantum optimizer without any prior knowledge and to implement and how to implement this optimizer for the real-time use cases. So QS is basically right now I'm working on the three verticals. This is my three goals, and these all three project is running project. Other than that, I will share later to Pavan sir. So what other like opportunities I'm looking for the association also. So first project is right now is going the Korean projects. Here we are working on the QRL based particularly. Second is some DRDO. A defense project is, and we have already patented the quantum development of Schrodinger channels. And third is my Navy project, and I'm looking a collaborator also in this particular to academia, industry, even some internship is also still open in this my third goal. So now coming to this, so start from the story. See, this my first question to user, what is quantum and who started this terminology? So everybody know about this. This the quantum is like a first time the Planck started. That the terminology is the quanta is basically, and this quanta is basically it's a packets of light something. But in 1925 sorry, in 1900, Planck was somehow stuck with how it's actually what is the nature of the quantize. And then the Einstein is in 1905, they actually describe about the, it is somehow is the wave like a nature. And then 1925, many scientists came, Heisenberg, Dirac, Schrodinger, Born, and de Broglie. These five scientists started to describing the quantum terminology. And why the Schrodinger is very close to me, because my PhD topic is on Schrodinger dynamics. So I have always putting the first name is a Schrodinger, and this is what exactly is. So the Schrodinger is first time 1925 and 26 somehow. So they're describing the actual definition of the quantum. So he said that quantum is a mathematical framework we describe by wave function, and that wave function described by Schrodinger equation. And that statement also written, there is a very famous book I'm always suggesting to everyone, that is a quantum computation and quantum information written by Nansen and Choi. And then Heisenberg came. There's basically they're describing the some uncertainty principle of this quantum. But in 1926, the first time the Born actually explained or interpretation of the given statistical predictions of the variable. So what is the nature of this wave? So they describe in particularly this is the wave. Wave is basically this nature of the probabilistic side or nature or statistical nature. And then the actual validation the first time in 1925 is basically to this is the what exactly the quantum behavior on somehow is to. And then all the notation somehow is to describe by the Dirac or Dirac delta equation. You know that that is the basically one. And then year goes and somehow is to in 1982 the year or 1981 or 82 the first time the Feynman proposed the idea to let's start but create some machine-based device which is basically the based on the law of quantum mechanics. And they proposed the idea in front of the IBM first time. But at that time, IBM was too earlier, and I always said in other way like they rejected our idea, but not rejected in that sense. They are started somewhere, but they are not somehow too ready to start or developing the quantum computing and all. And you know that right now, who is the biggest stakeholder in this domain or in this world is right now the IBM is basically. So somehow is the 82 is rejected to selected some to creating the big ecosystem to quantum computer and something like that. And then 85, 94, and 97. This year is again very renowned or remarkable year when the first time the Turing machine is basically that David Dutch they developed the universal quantum circuit particularly, and at 94 and 95, 97, the first two quantum algorithm is actually the first time in the domain of the source algorithm and Grover search algorithm. So people started to like this Grover search or somehow do source algorithm, source for the, like again saying that you can start the communication side particularly to security side, and the Grover is for any all the supply chain or any other use cases also particularly. And then year in 2022, that year is again very remarkable year. The first time the three scientists got the Nobel Prize based on the all the experimental, the tested the entangled photons, establishing the violation of the Bell inequality. And today I will show a small demonstration also about, if the time is somehow is to, definitely I will show the how the Bell inequality, what is exactly the violation of the Bell inequality, but still the photons are entangled. And the back-to-back 23, again, the three scientists got the Nobel Prize. And that year is, for me, is very, I mean, when the Navy got, accept my idea, which is basically based on the develop the quantum radar, based on the quantum dot technology. And I'm basically working on that particular, the graphene quantum dots using for the photon generations and to application in the Navy or defense to developing the quantum radar. 23 or 24 is some the AI based some applications. That is also some, if you are connected with the somehow the neural network on QNN, that is somehow is also. But 25 this year is again I mean 23 25 year is again, it's a remarkable for the quantum journeys, particularly to got the Nobel Prize discovery of the microscopic tunneling effect or some of the electricity. So see, this is the chronology from the 1900 to 2025. So how the people started and somehow as to where to stuck and where to support. So I always think to start from the 1925. So this is the first definition. And if you're connect with this slide now, the previous one is this is the story timeline. And if you're connect with this slide, you will develop today even you can connect or you can develop a quantum algorithm or somehow to any of the use cases. So as I said that what is a quantum? The first definition, because I am an engineer, I did my BTech, MTech, PhD, and then postdoc on somehow is to okay, I as an electronics engineer to quantum engineer. So obviously it was very difficult when I started a journey as a PhD scholar to 2010 or somehow is to nearby some. So it was very difficult to understand how the quantum and how where to apply and how to apply particularly. Then I found one very beautiful definition on Nelson and Chang quantum. He said, because I'm not a physician mathematician, so always you have to think about the engineering prospect. So I found that the one definition was there. The quantum is basically it's a mathematical framework. Okay, it should be mathematics, it should be physics, but it's a framework. And that entire ecosystem, that the framework that particularly that described by wave function. And if you're talking about that wave function, means that is the same the electromagnetic wave. And we know that electromagnetic wave e to the power minus j omega t, that is same the electromagnetic wave. And that means if the find out the solution of the Schrodinger equation, the output should be as comparable to wave functions or related to the wave function. When I solved this Schrodinger equation using the same terminology, then I found, okay, this is the e to the power minus j. In a wave equation is omega, here is h. And that h is basically, it's nothing, it's a total energy particularly. So in quantum is basically, it's talking about the energy waste, some eigenstate or energy states, okay? And that is actually the complex exponential signal. So because of that reason, the Schrodinger or that book mentioned that it is a framework, mathematical framework, and that mathematical framework described by wave function. And that wave function basically described by Schrodinger equation. So if you are connect with the Schrodinger equation and find the solutions of the first order Schrodinger equation, you can see there is a one equation in the right side, e to the power minus j h t. This is the simple equations, output of that. Okay, this is the clear. Now it is coming to the, what is the postulate? If you connect with this today, the definition, now the second is the postulate. Postulate is basically, you can understand the whole the process. So I mentioned here only three postulate, but actually it's a four. Okay. So what is the postulate? Postulate is basically every step of the process. Like initially, what should be like before this talk, Pavan sir informed everyone like today 6 o'clock. There one speaker. They will give a talk on quantum and somehow is too. Okay. So everybody, what exactly you prepared your energy like just talking about the connect with the my terminology. You prepared your okay and sit in your chair on your nearby your home and all, and then what exactly you prepared your energy. The same thing when you start your process. somehow is to before the class or before this talk, everybody has started your preparation. So same like that, the first postulate is basically talking about the state preparation, state space. State means energy state. Okay. So all the states should be coherent. Like I presume that right now all the 100 people are somehow is supposed to be sitting in this this call, some this meeting or some so everybody are entangled. Okay, and then ma'am describe about that my what is this quantum, and then they said okay, now you have to start. Now when I started my talk, that means this process, and that is called evolution particularly. Now the evolution started, but somehow is true. Okay, so first, what exactly? When you start working on the quantum side, first you have to prepare your state. First, second postulate said that the process, I mean evolution. Now this 1 hour or 2 hour or 3 hour talk is particularly its evolutions. Now after evolutions, I presume that the output shot of this FDP should be 100%. That means the unitary. Like, but I know that this is a practical, it's very difficult to connect with all the my terminology, what exactly I'm using and now. Obviously, in ideally, it's not possible to getting all my stuff or information in your repository or in your mind, particularly. So obviously, the same thing, the quantum computing is also working on in the real time. It's very difficult to maintain the unitarity. This is another thing. And how you're supposed to be the Pavan studies, let's okay, this circulate the feedback form and measuring this how much talk is supposed to be for benefited by our for all the users. So this is called the third postulate is basically talking about the measurement. So measurement is nothing but just Pavan sir sharing your feedback form. So they are measuring this feedback form based on your grabbing what exactly. If everybody is fitting like 100, that means the evolution is unitarity. If you somebody is no, it's not 100 and somehow so, some information is missing and something like that. But ideally it should be unitary. This is the what exactly is the quantum computer is basically. But why it's not yet to become the quantum computer? Because when you start somebody started to journey to develop a quantum computer, because it's a working on the atomic and subatomic level, loss of disturbance, because in classically you are just only considered the internal noise, but in quantum side you are also the quantum is very, I mean, very sensitive like a baby. Okay, and they are always interacting, interfacing with the bath state or environmental, and they lost or they maybe they face the decoherence particularly. So when started everybody be current after 3 hours, maybe somebody are lacking, somebody are disconnected, somebody did not understand, many things will be happening during this talk also. The same thing is the quantum computer is also like that. So what exactly is basically, so my job is to, if anybody had a doubt something, they will ask the question and then I am trying to rectify or somehow to satisfy something. So what exactly I am trying to maintaining this unitarity. So your job is to also, when you start a work on the quantum computing or something, first you have to start to verify whether the output of this particularly the second stage, it should be unitary or not. Unitary means all the diagonal elements should be one and upper and lower triangle matters zero. If it is not, then your job is first to maintain this unitarity. When you start maintaining this unitarity, then your job is next is to develop a quantum optimizer and something. And fourth postulate is basically it's a composite system. If the multiple quantum system are basically working together and something, but right now we don't have any one quantum computer. So for this talk until 2030, 35, and somehow it's 30, you're just bothering about the only three postulate. Okay, so this is the what exactly the story of the. If you connect with this the postulate, now I will start to how we are prepared the states, how you are maintaining the unitarity, and what is exactly the measurement also. Okay, now this slide is because definitely the people will ask you why you want to shift or join as a quantum computing. And this slide is somehow is to I am sharing two problem statement also. It's not only that I'm talking about the significant what exactly. The first quantum computing application is basically or somehow is to difference. Obviously, it's advantages. It's calculated by the qubits. It represents the 0 and 1 at the same time. But in classically, it's a transistor, it's a on and off, it's a switch at the either 0 and 1. This is one, it's like a disadvantage of the classical. Second is when the number of qubits will increase, the power is increases. That means this is a big drawback of the quantum system is particularly. In classical computer, obviously it's a number of transistors, it's a relation, and somehow is to one to one, and somewhere is the linear based on something like that. So power is, it depends on the increasing of the based on your, it's a transistor which is based, which is basically the linear. But in quantum side, if when you're increasing the number of qubits, the power is increases exponentially. This is the biggest drawback. Now I'm saying here one problem statement. Is it possible to develop a low power, a low power dissipated quantum gate with the limited number of qubits? The one problem is, I'm repeating one. Is it possible to develop or realize low power dissipated quantum gate with limited qubits? This is one problem statement. I'm looking a person and one. Second is, again, it's a big drawback. What exactly? When the quantum computer having a high error rate, it's a need a kept ultra code. Again, I'm saying in the classical, it's a very low error rate, and see that your computer is also sitting in the room temperature, and if the outside the temperature is goes -1 or -2 or somehow is the +50, don't bother about that. Your computer is still working. But in quantum computer, it's very difficult to somehow is to maintaining the ultra code. Now I'm saying here another problem statement. What exactly? Is it possible to develop a, a fault tolerance based quantum computer with low error rate at room temperature? I'm repeating the problem statement here. Is it possible to develop a fault tolerance based quantum computer in with low power rate or low error rate in room temperature? If it is possible, just ping me. I'm just giving a small clue about that. You just pick the quantum dots or ion trap. These two are basically, I'm working on the ion trap also, and it is possible on the room temperature also. Now the coming to the third point. And fourth point. Fourth point is what exactly today we are sitting and talking about. Quantum computer will help for the large number of, I worked at South Korea as a postdoctor. I used the billions of data for the routing problem particularly. And I used only 5 qubits. And I said that I'm not a big fan of the increasing the number of qubits. So I'm working on the downscaling. So my suggestion also today, I will show you also some demonstration, small demonstration, how you can also start working with the limited qubits with the some use cases, and which is basically one of the use cases in transportations. But in classically, it's not possible. It's very difficult to handling all this. Lots of handling. And if you're going and visiting the port side, if anybody are not visited, definitely will. Hopefully, if you connect with me in future, definitely will go. There's many hurdles and port sides. And it's very difficult to maintaining the from the uploading to downloading, downloading to yard to exit. Meaning one day in a Kandla port, I saw 10,000 plus bus. I mean, truck is basically out and exiting. So this is what exactly entering and now exiting is particularly. So now it's time to come on the how to handle in a fraction of seconds, somehow to 50 second or somehow it in given time of frame or very small time of frame, you can optimize the task, all the like in particular all the use cases. So first and fourth are advantages. Second and third are disadvantage. But now I'm not supposed to be here talking. This is a disadvantage. This is a problem statement. One, possible low power dissipated gate with a limited qubit. Second is if it is possible to develop a quantum fault tolerance gate with a low error rate in the room temperature. Okay. Now coming to this three property, everybody is talking about the entanglement, superpositions, and particularly for correlation. So this is the three stories basically in how it's supposed to be. And based on this diagram, you can understand that superposition means what exactly is basically at the same time the system is a two or more of the states simultaneously as connected, and in single particle can travel with the two different paths, something like that. Okay, so it's like a wave particle in nature. I said that in 1905 already the Einstein said that the nature of the quanta is the wave like nature. Okay, and then in the 1925 the mathematically they proven the Schrodinger is basically to the power minus j omega t or something like that. Second is all the physical quantities somehow is two and more particles are correlated like that. If you're in superpositions and something, so all the qubits are correlated each other. And if it is entangled ones, and they suppose they are break it somehow, so somebody is sitting in the northern plate, somebody is sitting in the southern plate, then still they are entangled each other particularly. And that method is basically first time tested in 2022, and three scientists got the Nobel Prize based on that Bell. Bell said that always it's a 50%, equally probable, like 50% up and 50% down, or 25, 25, 25, like that. Always equiparable. But they tested on that after the violation of the Bell inequality, still the photons are entangled, particularly. Now coming to that, the notation, because you can understand so how the Dirac is coming into the picture particularly. So the notation is basically 0 and 1, cat 0 and cat 1 is particularly it's up and down spin, like a particle are dancing in the either up spin and down spin particularly. And if it is a single qubit, there is a two possible state like cat 0 and cat 1. You can represent it the cat or bra like that. Bracket, it's like a both are complex conjugate particularly. So either you can represent, but all the book are particular, they are using uh, cat 0, cat vector. And it is a basically, it's a column vector. So cat 0 is basically, if you see this equation, this particular here, the matrix, it's a 1 and 0. It's a column, and cat 1 is basically 0 and how is supposed to be like a not in the mathematical, just as a conceptual base. Like suppose you are sitting in or standing on equator particularly, and cat 0 is supposed to be located on northern pole, and now you can start and equator is 0. Okay, like particularly, so you can start your journey from equator to northern pole. So equator is 0, and then you can start to towards northern pole. So when somebody are sitting or cat 0 is sitting on northern pole, that is lies 1. So it's right as 0 to 1. Now coming to the cat 1, cat 1 is basically, it's a cat 1 is written on southern pole. So you can start like a downward. So 0 to 1, like that. So this is the basically how you can write a matrix of this single qubits particularly. And if you are write two qubits particularly, so how many combinations? The two qubits means there is a four combination, 2 to the power n. Okay, so 0, 0, 0, 1, 1, 0, 1, 1. So how to write a matrix of each qubit? So first is 0, 0. So 0, 0 means 0 tensor 0 particularly. So if you are tensoring product of 1, 0 tensor with 0, 1, it's like the multiply of the entire matrix into each column, each elements. Like if you multiply with 1 into 0 into 1, you multiply into 0 and 0 into 1. So if you want to write the matrix of 0, 0, what is that? 1, 0, 0, 0, like that. Same you can write a multiplication of cat 0 and cat 1, like a second bit is 0, 0, then 0, 1. So if you are taking the tensoring product of cat 0 and cat 1, you can you can receive like a 0, 1, 0, 0. Then again you can third is 1, 0. So tensoring of 1 with tensor of 0. So you will get like a 0, 0, 1, 0. And the last vector is cat 1, 1. So how we can write cat 1 tensor with cat 1. So you will get 0, 0, 0, 1. And now you have to accumulate all this. So you can see that when you accumulated from all this, it's like a 1, 1, 1. All the diagonal elements should be 1, and upper and lower triangle matrix should be 0. You can try in your home and also, and then you can write a 3 qubits. 3 qubits means 2 to the power 3 means 8, like the how many combinations? 0, 0, 0, 2, 1, 1, 1. So you can start like the cat 0 tensor cat 0 tensor cat 1, the same like you can start like a tensoring 1, 0 tensoring 0, 1, 0 tensoring 1, 0. So first you have to operate the 2, and then again after the getting the output of first, then you can again tensor with the another one. So it's like the same, it's the 8 cross 8 matrix, and the same the all the diagonal elements should be like the 1, and upper and lower triangles should be 0. So it's like a unitary, right? Now coming to the, based on this representation, all the states, energy state, you are representing the matrix form. Now here another scientist actually they explained in 1925, because obviously if somebody are explaining the definition or mathematical, somebody are explaining about like what is exactly the matrix mechanism. So quantum mechanics, based on this explanation, another definition came. The quantum mechanics is also matrix mechanism. One definition, quantum mechanics is the mathematical framework we described by Schrodinger. Second definition, based on all the representation based on the matrix, which is basically given by the Heisenberg particularly. Now coming to the third equation, say that if you're writing a state equation, cat psi is equal to A, cat psi B, and if you're taking A and B, the mod of A plus mod of B squared, it's maximum. I said now the output of the evolution should be 1. 1 means 100% probability. That means, so this is unit norms. Okay. So based on that equation, it is basically it's a probabilistic mechanism. So quantum mechanics, another definition is quantum mechanics is also probabilistic mechanism because the maximum probability should be 1. Okay, so this is what exactly. So three definition, and which who gave that this particular the interpretation is given by the board. The board basically who actually explains statistical behavior or probabilistic behavior of this all the wave function particularly. Okay, now the last is all the operation of the quantum mechanics, it should be reversible, but Boolean operation are not reversible, not possible. So if you want to suppose to be your operation or quantum gate should be unitarity, it should be reversible. Okay, and if it is reversible, then obviously it's allow the unitary matrix or just follow the unitary matrix. And how it's a unitary? It's look like that. So like this is the what exactly the output of the unitary. Unitary means all the diagonal elements should be like 1 and 1 and upper and lower terminal. So your job is basically if you want to develop a quantum gate, 2 qubits, 3 qubits, 4 qubits, first you have to test whether your quantum computer or quantum gate or output of the quantum process or circuitry should be unitary or not. If it is not, obviously practically it's not possible. Okay. So now your job is to how to maintain your unitarity condition. This is the biggest actually the problem statement in everywhere. Now, second is which system supposed to be like. I always suggested like you can start from the harmonic oscillator, the basic quantum system. Then you can choose either superconductive, ion trap, NV atom, quantum dots, Redberg atom, NMR. You can choose like as a classical computer, you know that somebody are using HP, somebody are using the Apple, somebody are using Dell and some Apple and something like that. So same like that, which quantum computer do you want to like? You want to, our today talk, I'm just saying that if you are interested to work on low power dissipated gate with the low error rate, you can choose ion trap. My suggestion. I'm not saying you can start ion trap, okay? It's my suggestion, okay? You can start ion trap for the room temperature particularly. So if you want to work on the ion trap, now what is should be very important. So first, obviously, state preparation in terms of the energy. Energy is technical term is basically it's talking about the Hamiltonian, right? So if you want to develop a Hamiltonian of the any of the quantum system, first job is you have to prepare your Hamiltonian, and then you can apply this Hamiltonian or incorporate the wave function, which is basically we are talking about the Schrodinger equation, right? Now, this is the basically the story, what exactly is right now, what exactly I'm talking about that. So this block diagram is very important. Why supposed to be anybody want to develop a quantum operation or develop a quantum circuit, develop a quantum gate, develop a quantum algorithm, develop a quantum gate-based security, anything like that. This phenomenon, this block diagram is very important, particularly. Why is supposed to be important? Is I said that first, you have to identify what quantum system is supposed to be you want to work, either superconductive or ion trap, harmonic oscillator, anything like that. So if I will choose harmonic oscillator, so okay, sir, I will start harmonic oscillator. Okay. So I said, okay, if first you have to choose a system, then you have to find out what is the Hamiltonian of the quantum. Hamiltonian is what exactly is very simple term. It's a layman. Hamiltonian is nothing but it's an energy. And you know that everybody's know about that. Energy means total energy is a kinetic energy plus potential energy. The same. And the kinetic energy is basically what is exactly is p square by 2 if you are talking about the momentum points of point of view. And potential you just have to consider as a potential. Now what will change? Initially, you can consider your momentum. Like in this talk, I am considering all your potential, sorry, all your momentum. But when my talk started, I'm not bothering about what is your momentum right now. I'm bothering about only your potentials. What level of potential you are supposed to be grabbing right now? Because a 30-minute talk is already completed. So what level of energy state is somehow is obviously there is many disturbance occurs in your mind, in external and something, but you are holding your potential right now. What exactly you're talking about the energy. So initially, the when talk started, I am considering the all the Hamiltonian should be zero, like H0. So at initially, everybody momentum is okay, potential is okay. But when this talk started, what will be the next? Like after this t is equal to 30 second or 30 minute, what is the potential? Now I said I am bothering about only your moment on your potential. Now I will check what is the potential of this time particularly. So initially the Hamiltonian is H naught plus the next level of the potential epsilon. Epsilon is basically, this is the process, like a disturbance. Like you are starting grabbing, something is missing, some information, some disturbance, something is happening in your nearer there. And this is epsilon. And then because of this epsilon, your potential will change somehow too. Okay. Now I will find out what exactly the Hamiltonian. So this whole the system is I am talking about, it's a agent. So when your quantum computer is up, you can start your work on a quantum gate or something. First, you have to prepare your agent. And more layman term, like in that, in Dakia, suppose the postman, they are basically your agent. What exactly the postman is? The postmaster or somehow they said that this is your informations. Later, you have to just send this information to destination particularly. Now the postman start the process. So the postman is basically here the Hamiltonian. This is agent. And that should be very important. Have to first prepare your agent. This agent have to check whether, like if somebody will come, sir, I am preparing, or I already prepared Hamiltonian. My first question is, what type of Hamiltonian is supposed to be, like harmonic oscillator, superconductive, ion trap, NBATM, NMR, what type? You said, no, sir, I'm preparing the harmonic oscillator. So, okay. So what is the Hamiltonian? So initially H naught is the same, sir. The plus next level of Hamiltonian is basically the harmonic. You have to find out the Hamiltonian of. So this is something you have to find the potential of the harmonic oscillator. So like you have to just find the potential and put the value of the VT, and then you have to incorporate. Now, second stage, when you start, when you're ready your Hamiltonian, this one more thing is very important. This V and H are not commute each other. The V is actually your information carrier, like a lifafa is something like that. So this Dakia, like a postman, will not actually open your letter also, because they are not commute each other. Some ethics is also there, no? So same thing, like in quantum computing, the quantum ethics is there. So this Hamiltonian is not interact with your VT, because they are not commute each other. They are just bothering about what exactly the VT will carry, whether it will be the VRP data, whether it will be the security data, whatever. So who will carry your informations is VT, and VT is actually your that is real agent. And then you have to send, you have to prepare, and then start your process. Now the second is operation. As I said, this operation should be uh, it's unitary. Now the label, this here is measurement side. Here you have to check whether this operation, ideally, if you connect with that slide, postulate slide, I said unitary evolutions, right? Unitary evolution means the operation should be, ideally, it should be unitary. So you have to check whether this matrix should be unitary or not. If it is not unitary, now your job is basically will start here, how to actually maintain the unitary. So quantum system, as I said, that it's working on the atomic and subatomic level, means it's a infinite dimension somehow is too. So your job is, first you have to discretize to convert infinite to finite. So I developed one method here during my PhD, which is basically the truncated Dyson series. I use the Dyson series truncations. So I discretize, I basically this all this continuous to discrete domain. Now, if this is output is suppose UT, now the after discretization, just you have to change T to caps T. So here you can write your U of T. Now your discretized unitary gate is ready, but you don't know what is exactly the matrix is, because whether it will be unitary or not, it's you have to check or compare. Then I compare with the ideal to derived one. This UT is a derived unitary gate. Ideal is always it should be unitary. All the diagonal elements should be one and upper and lower. So what exactly your job is to find out the discrepancy between the given unitary gate and derived unitary gate. Okay, and then whether you have to check, then you have to use the cost function. I use normally the cost function is Frobenius norms cost function. Particularly, I'm not suggesting to everyone to use the same cost function what I used, but obviously it's already tested. So my suggestion is to have to also try to find out the other cost function, and then you can use my cost function also, like the same thing. So, okay, so now I use the cost function here though. So what exactly it is? The output of the cost function, it should be the gate error energy, means you have to check whether the error should be minimum or not. If suppose UG minus UT is approachable to zero, like that. So what is the zeta mean output is UG is equal to or approachable about to UT. Means it's like a all, if you are getting the any output of the unitary the matrix, it's like a diagonal elements is like a if 0.9, 0.8, 0.98, something like that, and upper and lower triangular matrix like a 0.02, something like that. Your job is done particularly. So this is the process how you can start. Now I will describe this block diagram into step wise and how you will choose each step, how you choose the Hamiltonian, how you choose the process. But if you're overall, you can connect. If you somebody will to want to start develop a quantum control gate or any gate something, this is the whole the process to develop a quantum gate for the any of the use cases. Now coming to this, I'm always suggesting to go my paper 2015 paper. I develop a some algorithm to for 2 qubit to n qubits also, but I am using during that time 3 qubits. So this is what exactly the how to implement the control gate of the 3 qubits. My suggestion is to start your and detail this the descriptions is already in 2015 paper. I already there. So you can use just only develop a one control gate and forget about anything like that. Then I'm suggesting to use the control to phase gate only. Okay, if somebody are start and all, people are many are using the n number of gate and all. Please stay away from these all this. You can use just one control gate and apply any of the use cases what exactly is right now is there and somehow is. Okay, so already I developed something and you can use the same algorithm for the n qubit, I mean 3 qubit to 5, 5 to 10. But my suggestion is to go for the first five till five, and then you can start to use the swap circuit, swap gate particularly for reducing the qubits. I said that I'm working on the downscaling. So you can also why I'm working on downscaling to actually there is the two problem. One is decoherence because the interference of some internal and external, and second is dissipation. As I said that no second objective is basically dissipation. The high power is basically. So your job is also somehow is to identify that these two and stay away from them and find out the solutions. Dissipation and decoherence. Most of the people are talking about the decoherence and all, but my suggestion is to also think about the dissipation side. Means if you are increasing the number of qubits, oh, the power is increases also. Not think about that. How is it possible the low power dissipated gate with a limited number of qubits also? So this is the what exactly the algorithm, and this is the matrix. And then you have to check whether the noise to signal ratio particularly, because why it's a noise to signal energy ratio, not the power particularly, because because here all the states are talking about the energy. So I have to find out the noise to signal energy ratio. In quantum system it's energy. Okay, so you have to just this is what exactly the performance criteria, and check whether it should be exponentially decay or not. If it is somehow is to the first overshoot is somehow is to is one or nearby one, and its goal for the less than is supposed to be 0.02 and something, your quantum system is basically perfect quantum system you develop, or perfect quantum gate you are supposed to develop. So this is all I already described in my paper in 2015 paper. You can go and visit that paper. It's already there. Even I shared my PhD thesis on LinkedIn also. Sorry, on archive. It's open access. So anybody can just read and connect with all this, what exactly I'm talking about terminology. And then if anybody has somehow to doubt and something, you can connect with me. That's one nice. Okay, so now coming to the solution side particularly. So this is what I said that. Now the solution is basically if somebody had started working on the optimization and some particular case. But before optimization, I'm just sharing a small story. When I visited last year to Kandla port, so as a quantum guy, I started like, oh, no, okay, after coming, like I came to India last year before and then think about that because I developed some quantum algorithm for Hyundai. So lots of hope is somehow is there. So I visited the Kandla port and so and discussed with the secretary and so that. So I'm planning to apply my quantum algorithm for maritime and all these that. I mean, high hope and the high passion. So my secretary said that, okay, you have to please just go and visit Kandla port. When I saw and visited and saw this scenario, I was speechless. And why is supposed to be quantum or AI somehow is to work or something? If you have a data set, then it will work. But the first, like when I visited, they don't have any data set, digital data set particularly. So now your first job is to already now the last year, last week or maybe last week, the Kandla port announced the India's first digital port. Now we are happy. Okay, so first module is supposed to be generate your data module, depot data, vehicle data, picking, all this. So this is another problem statement in all the ports right now. If any professors or any researcher somehow to any application or any method, you know that how to generate or how to like a convert method is somehow is to convert all the raw or scanned something information to convert into digital data. This is another a big problem statement and project is there in all port. Very soon they will announce. Second is if somebody had started like a data management. Second is the data management module of the optimizer side. Like already the D-Wave optimizer is there. Many people are working on the QA or annular side. And I'm working on the meta heuristic approach, like a PSO, GSO, GWO, or something like that. I developed something on GWO, GSA. And recently my PhD student, MTech student, they developed something on some gray wolf optimizer base. One of my project, I said the first slide, they're accepted by the BHO side. So I'm suggesting to also explore your meta-heuristic approach to develop a quantum inspired meta-heuristic for any of the application. Now the two modules set up ready. Now come into the control module. The control module is basically they can cop up like data with your optimizer and they can start. And that control module is basically who is controlling? The Hamiltonian. Now your Hamiltonian, here the Hamiltonian will work. When your Hamiltonian is carry your data input or something like that, and then you feed into the quantum system, then in quantum system it start the working, and then you take this module of the heuristic and the output is looks like that. Like one depot, this is the one depot, and here is the four vehicle, I mean four destination point, and there is a four vehicle. So this is what exactly is. So yeah, this is called vehicle routing problem particularly. If you are using the one vehicle, the call is TSP problem, traveling sales problem. So one vehicle will entire, they can visit all the destination and come back to the depot side, but you can use the multiple vehicles. So this is called actually. Now here is the another problem statement is it possible to connect or somehow is to connect the satellite particularly? So this is another problem statement. If somebody are working on this something like that in satellite base to connect all the information, sending this and they start the working on this, then it's a vehicle not now you are start because the now the EV era is started. All the vehicles supposed to be very soon will replace the EV. Now you can start like find out the closest charging station nearby your home also. So you can start like a work like that. You can develop your same algorithm for the EVs industry. Recently, the Amul is also a problem. They are setting some problem statement and based on that. So now you can also start with working on this Amul industry and means milk industry for the same optimizer. And one more is recently is the helicopter, the industry, the PSU's name is the Pawan Hans. They already announced there is a one project that is called the Heli Pilgrims, Kedarnath, Amarnath, and Katra. They are also looking at people who can expert in the AI on QC to how to maintenance size, particularly in logistics. So there is huge demand in some hours too. First, only you can start, you can develop. Once you have developed your algorithm, you can find the solutions, you can find the some applications, and you can apply something. And either you can connect with me, and I'm working on the various these are sectors where I'm trying to apply my problems. Now the coming to this some mathematical problem, because I said that mathematically stuffing is very important to all this. So if you connect with this, just I'm recalling once. If you connect with this diagram, now I am expanding each blocks or I am trying to explore the each blocks, how this cost function till now, this is only for cost function. But next slide, what exactly I will show you, that means how your control gate is basically to cope up with your optimizer. And I am showing one optimizer, which is called a gravitational search algorithm. So if you're somehow is to understand about the GSO is basically it's a mass-based optimizer. So larger the mass, optimal the value. This is the what exactly concept. So there is a fourth section. If you just connect with the first, see this first section. First section, I'm just developing the Hamiltonian. So this Hamiltonian is unperturbed, means this H naught, and perturbed Hamiltonian is basically the VT. And now I am putting this, I said that this VT is your Dakia, your postman. So who will carry your this information? or data, this VT. So this VT is modulate with the this agent. Sorry, ST is modulate with the VT, and then you can add with the Hamiltonian or energy. Hamiltonian is always initial, means when my talk started at that time Hamiltonian. When this talk is somehow is 1 hour is finished, this now we have to talking about the right, what is the Hamiltonian of right now. So right now your Hamiltonian is talking about only the in terms of the moment, sorry, potential. Okay, and that potential will carry all this information. Now, when you prepare the Hamiltonian, now you have to feed into the quantum system. See, initially this input is a psi t because it's a wave function. So psi t, and you can write the Schrodinger equation. This is the first order Schrodinger equation. See, if I ask to anyone, what is the output of the this quantum system? So ideally, many time I ask, many times like what is the output of the quantum system? So if ideally, if suppose I will ask you, it's ideally is what exactly? It's same. It's a nature change, psi t to ut, because it's a unitary evolution, right? So the output of whatever the output of this psi t, the output of the this quantum system is also same. Just because I mentioned that it's a unitary, so I just change the nature or just change the cloth. Here is the red cloth, here is a black cloth, something like that. But inside the all this, who is basically carry the cloth? Either you and me, something like that. The solution is the same. Just we are writing the equation is something. Here we are writing this psi t. Here we are writing in the form of ut. Now you have to check what is the unitary, what is the output of this. If it is unitary, the job is done. But obviously, practically, it is not possible unitary. Then you can start the third sections. The third section, you can truncate it first, and then you have to just derive this first order till first order, and have to compare with this ideal one and find the cost function. And the cost function, I mentioned that I use the Probius norms. You have to also use the same or whatever the main cost function is there. And then after that, you have to check whether this gate error energy function should be minimum or not. If you're not supposed to minimum, your job is not done, and still you have to trying to find out the way how to unitary, how to minimum. Once it minimum, then you can apply your any of the optimizer. See, the quantum optimization means first it will all it will cover all the process, quantum process, and then you can apply your classical. So it is basically quantum inspired based meta heuristic optimizer. And then I applied the QGSO. Here I just incorporate in the cost function, and then we have estimated the mass. And this mass is basically, see this, if you're deriving the equation, this mass is basically depends on your this data. And then you have to find the larger the mass, optimal the value. This is the what exactly the concept. And then you are getting the optimal path. This is the whole process. You can also start, you can change this GSO to BHO. We can change the BHO to GWO. You can change the GSO to even GA, generic algorithm. Any meta heuristic apply, you can start your work and try to find out the what is the basically the core logic of the any classical meta heuristic, and then apply into the quantum inspired base, and it will start like an optimal cell. But you have to check whether it's a local minima or the global minima. Many criteria is also based on that. I decided to start working on the GSO side. So this slide I will share everyone also. And then I bifurcated section wise how the first section incorporate the data. Second section, if you're in build the H, then second section you can just find out the UT. Then third section, just simple QFT gate. And then fourth section is some complete the, you could get the optimal data. So this is my result. What exactly I use the 3 qubits, 10 CT, 1 depot. The red is the depot particularly, and all these dots, blue dots is basically CT. So I'm using 3 vehicles. So the vehicle is defined already. This automatically they decide first vehicle is red, then green, and this, and back to the depot also. This is what exactly I'm using the. Here I'm using the 3 qubits for 3 vehicles, and later I till now I'm using 25 qubits and reduce up to the 10 qubits also. Okay, so this is the some prerequisite. This is very important for particular. So what should be needed? It's all the Hamiltonian and H and V should be Hermitian. Another is very important should be. So if you're taking any matrix and the matrix of the H and V, first you have to convert in the Hermitian form. So then I converted all the Hermitian, and then I started something like this. And see this, my first overshoot is very 0.08 and it goes to like 0.01. So this is the best result of my optimizer of the GS or something like that. So this is the matrix of something 0.01, and then getting this is basically the my performance criteria of the quantum gates particularly. So this is the what exactly the problem statement. So it's a NPR. So your job is to minimum cost, minimum distance, and minimum travel time also. If I'm just sharing one video for maritime, and if voice is audible or not, please confirm me. So voice is audible? Anyone, please?
No, sir.
No, no. Voice is not audible. Hello?
No. No, sir. No.
Okay, 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 no problem. I will share the what exactly is this video is somehow is to what is the shipping industry problem right now. I prepared the 1 minute video. I will share to everyone. Let's just connect with this the story video, and then why should be needed this optimizer or quantum optimizer or any optimizer somehow is to in right now in the quantum era particularly. So now the coming to the my problem statement is particularly our mission is basically to looking a person or also to shipping industry, and obviously it's to reduce the cost, enhance the sustainability and all, to in the real time analysis. But how I started something like that? So I discussed with the many. I visited to DHL port also, and then I found out the main pinpoint. See this: if you want to develop a something in anything like that on quantum side on something, first you have to understood about what are the problem statement. When I visited and this Kandla port and something, what exactly the cargo side, still there is inefficient the cargo load optimization. One, because of that reason, there's high fuel consumption and emission is basically, and this is what exactly the government and the Modi ji just announced last year too, green energy or somehow to hydrogen energy for particularly for in shipping industry. And there is a one center of excellence on the Kandla port also. And so if anybody are somehow is to working on the energy sector, the quantum in optimizations you can use in the energy sector, this is the big problem statement something. And then the third is very important: inaccurate storage planning and loading. I'm not criticizing to anyone like this. When I visited, I saw there is n number of like tinders and koilais like as a per hour like that is in the vessel. And I saw what exactly how people can supposed to be like, we are a quantum guy, we are a technocrat and somehow too. And then I shocked how I supposed to be, where to apply and how to apply this quantum technology and somehow too. So lots of difficulties is particularly, but what exactly the government is now is ready to move on some positive for side also. They are trying to interact with the academia to sort out to develop or some basic algorithm in the lab side, and then collaborate with the industry to find out these solutions and to resolve this solution for the this all this. And the fourth is difficult to handling the complex routing problem. So see, I am sharing the complete the quantum seed. So this is the vessel. Means right now, see, routing problem in the sea, it's very difficult because it's like a swapping based. It's not like a road and railway. In road and railway, it's you know the path, you know the actual. Okay, but in ship, you cannot identify where is the route. Obviously, there is a many difficulties, depth, sometimes tired, tiding, sometimes tsunami, and many things are occurs in any. So you have to also find out every time something like they will change the routes, they will change the something some path also. So for the sea routes it's very difficult, but obviously many company already now start the working on this side. But in India, if you want to work on the maritime, particularly in the industry of the maritime, you have to sit on the yard side. So here the government and the secretary said that you can start your yard optimization. So this diagram, if you connect with this one, the rails and all, so you have to just start the yard side. The truck will enter and exit, I mean arrive and departure from here, and there is the gate. Here gate is basically is like a, there is one, I mean in on Kandla port, the RFID, and that was also very old RFID. So he said that I visited to security also. So he said if anybody are somehow to working on the to change my RFID problem statement for the security side, this is another what exactly is. I don't know the Goa port is what exactly. Last week, last sorry, next week I'm going to Goa port, so I will see and will definitely will explore and we'll share the story of the Goa port also. So this is what exactly is your problem is to right now. Don't bother about the what is the security on. Your job is how truck is entering optimization, where is your container, how to putting the container. And second is there is another is loading and uploading one truck, another is this railways also. So this is your problem statement, particularly for applying this yard optimization. I am trying to, associated with some company which is basically AWS for the simulator and Gorobi. So very soon, probably this year and this month, probably we assign a one company MOU, and they will provide the all the licensing, the free version, because we are planning to start in the globally to how the shipping industry or any of the industry to start something. But my suggestion is to, sir, what exactly you are. Which simulator is basically, and everybody know about this QSkit, IBM QSkit, but I am also suggesting to explore some other simulator. Here I am using AWS, but one more simulator today I am just spreaded to everyone to name is QPS, Quantum Program Studio, and I will show you also some small demonstration. So how to develop a quantum algorithm, something like that. Okay, and then this the company name is so who is my competitor in particular is obviously D-Wave is my competitor always. So I am not using the D-Wave optimizer. Many intern and many professor are working on the QA or annular. So if you are interested and work on my this metaheuristic optimizer side, so I always inviting. So your job is a storage planning, loading planner, truck container to calling, one coast side, container to yard side, then container to truck calling from the yard. And this is the sixth problem is basically it's a security side. If anybody are supposed to be working on the RFID or some any security level, they can please connect with the gate assignment system, particularly on this also. And the last is consolidated bean packaging, which is already tested in the Airbus 2022. And the D-Wave has actually present that idea or take that idea somehow to bean packaging problem. So now, because today I'm talking is basically the yard side. So what is the yard is particularly? So yard is obviously it's a technically it's a very mixed integrated programming in what exactly utilization, and obviously some of the port in Los Angeles and some DHL Korea, they are using this some AI ML platforms. Right now, everybody is trying to utilize this D-Wave optimizer, that is a QA or annular. So I am suggesting to also you can, if you don't have any idea how to develop a quantum optimizer, so you just explore the D-Wave optimizer also. So from inbound and output efficiency, obviously it's very like how supposed to be truck calling and all. So your job is also to strategically to place the container to fast and retrieve. You can identify the where is supposed to be crane and container also. It should be efficiently or not. This is one reason. Metaheuristic is obviously it's you have to talk about the global minima and have to find out the which metaheuristic is basically to work on the global minima particularly. So like either evolutionary based, swarm based, or nature something like that. So I'm working on the some GSO, BHO, nature based. I'm not using GA. But if anybody are somehow GA with GSO, please come with me also. That also one of the problem statement where you can work this. Hello, this voice is audible.
Yes, sir.
Hello.
Yes, sir.
Yeah. So, okay. Yeah. Thank you. So I just said that genetically I am just proposing GA, DA, and evolutionary, and the swarm based is PSO, ACO, GWO. One of my student they develop a GWO, and my suggestion is to either you want to somebody are really they have a good knowledge in GA side, so just create a hybrid base GA with GSO, and one paper is already there I think on. Or some elsewhere on some things. You can just type a GA with GSO. There is one paper. So I'm trying to explore also some genetic based with the something like that. So if anybody are somehow is to working already on this categories, particular the metal stick, please come with me. Or if you're not supposed to be, to my suggestions to start your explore your the which classical optimizer or somehow is to much better as compared to the this one. Then I will put how you can develop a quantum inspired with something of algorithm for any other use cases. So this I said the IC Bangalore is already announced the one call a proposal, and there is one the objective is algorithm. So if date is very close now, is a 15 is the closing date, but today is I think 6. So we have enough date. So not too much, I mean, hazy application forms. You can start your work from the in 5 to 6 days. If any input from my side, I will always happy to give input this also. So this is what exactly the overview of the, I said that you can start your exploring how you can actually, based on the characteristic, you can pick one. If you fix it today, okay, I will start this one, please don't change, because if you will change, then it's very difficult to start something. So if you fix, no, sir, I will start a GA, stick on the GA and do that. Okay, at least now the time should be, you have to develop quantum inspired. Okay, if you will develop any of the inspired ways, now it will work. Okay. So why quantum? That I already told, I explained that is evolutionary. This is what exactly appropriate. Networking routing, vehicle routing, logistic optimization. These are use cases. This is the what exactly my student something will prepare the presentations. And if any idea about this GWO, I will share the paper also. We can start a work on the GWO also in the some other respect, because I mentioned this algorithm for the EVs industry right now. Now I'm planning to GWO for the in maritime particularly. And I already mentioned that how to develop a quantum inspired. So the method is same. You just replace the GSO into GW or any of the something like that. Okay. So this company, I mean, why it's very important for particularly, I said that I'm working on this developing something like that. And we are planning to give a SaaS-based solutions. So very soon, probably this year, we are planning to announce my algorithms also, particularly for this. So this is my paper, 2003 paper, first paper. I developed a quantum path integral. This is also another meta-heuristic approach, and it was published on IEEE transaction intelligence. So I already use the limited qubits. So you can follow this paper also, and you can actually just try to understand what is exactly the problem statement to how you're supposed to be like start this the meta heuristic approach. So recently, one of the companies very soon I start the collaboration. And so majorly goal is also we can plan to start some center of excellence, Technopark, where means techno in Gujarat government we signed a MOU with us, and very soon we'll develop a establishing the technology park particularly. And obviously, this is a FDP. What exactly? Thanks to Rajkumar Goyal College to organize this FDP for train all the students and training for the faculties and to train all the scientists and something like this. So this is very good approach and something for the educate the society, because really I generally I am just saying that I have a opportunity. I'm looking a person right now, but it's the lack of this. Because obviously, I'm if supposed to be, I'm saying today we are planning to develop a quantum radar. Somehow is to I'm based on quantum dots. So if anybody are interested on or idea about the quantum dots, please connect with this also, or any intern or PhD or MSc student or something like they're working on this. So most of the difficulties, and AICT is initiated this particularly for that to educate all this society, scientist, engineer, and then for the student also. So my startup is also recently last year selected. There's a big achievement for my is also is Bavaria is selected by both the startup. And Bavaria is announced recently to about to 10 billion. So this year they will announce also some Indo-Korean projects, sorry, Indo-German project, and the budget is somehow 10 billion USD also. So you can come and collaborate with some industry and participate on this call of proposal also. So this is my last year mission. I invited, and my intern is develop something, some protocols. So I'm not working on this 1D optimizer, but just what exactly my mission is also to develop and some more problem statement, and I will share. Recently, we selected my projects under the MIT also. This is what exactly I am sharing one problem statement here. Recently, the last year, I mean, I discussed with this some secretary, and they shared the problem statement. And even I posted on LinkedIn also to looking at this is 2017, the Mahakumbh in the Nasik. So I am looking people who are supposed to be. This is my problem statement. Is it possible to real time route optimization, crowd safety? via the quantum walk-based search. I mentioned here. So for the Kumbh Path Smart Management System. So this is what exactly, this is also another the real-time problem statement. And the last date is somehow is the June. So we have enough time to connect and to grab this opportunity. Not for the internship, even the faculty can also be a part of this project. And 2 months or 3 months is, I think, the Kumbh is basically so all the crowd management, any of the like path management, how to decide, and also this is very challenging also. So to how to supposed to be like to start working on this. But first job is to say here I mentioned that don't explore and don't think. You just pick and one problem, optimizer, quantum walk based, and this is the quantum walk is also it's a hybrid based but it is much better than as compared to the QA on all. So till now, I am just closing here because next talk is on the communication. But I want to interact for the some time being for the questionnaire side. This is a lots of software and these are my company. But I said that I am just taking 5 to 10 minutes more to show here the one optimizer, the hands-on, particularly QPS. Yeah. So if anybody has the computer side, you can just type in Google QPS simulator. Okay. And you can click on the first link here. And then I already registered here, so automatically it login. So first they will ask the registration part like this, like if you will supposed to be open, it looks like that. So first you have to kindly just registered, and then you will receive one notification on your mail. Just click on verify the notifications, and then you can again logged in here. You can type your email ID and something, and they will ask some questions or something, some more steps. You can just bypass yes, 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 and then you can just click on the new projects like that. They will ask the project. I'm just putting an ID really something, anything like this. Just okay, and then it's just click on continue. So they will ask okay, just click on okay and click on okay and this okay. So it's like that. Okay. So this is what exactly the I said no simulator. So this is the one simulator. Okay. So QPS. So my job is basically today will show you whatever I was discussing about to how to develop a quantum and all. So initially I'm just using 2 qubits gate. Is it audible and visible or not? Kindly just confirm once. Is it visible? Hello? Anyone please? Just confirm. Hello?
Yes, sir.
Okay. Is it audible?
Yes, sir. Yes.
Okay, okay, thank you. So now this QPS is how to build. So like same, if anybody are use the uh, this QSkit, so same like that. So what exactly you can just drag and leave, drag it and leave it. So I'm using here Hadmard gate, and if you are supposed to be using Hadmard gate, you just click in H and you can see this right side, all the matrix is there. So H matrix is basically 1 1 1 minus 1, and outside is 1 by root 2. So 1 by root 2, 1 1 1 1 1 like that. This you can see that. Okay, and even you can see this. What is the output? Like this is the output cat 0, and cat 0 output is, you know that if you're putting cat 0 in one Hadamard gate, just click on the blot sphere. The blot sphere is the green is already is here. If you are not supposed to using a Hadamard gate, you can just put here. Okay, I'm using a control gate. Sorry, X gate, not gate. So not gate is basically if you are putting 1 0, the output is 1. So you can see this. I said now the 1 is located in the northern pole. See this green, this dark, the dark line. This is basically if you are adding cascading one more X gate, then what is the output? 0 to 1 and 1 to 0. Just click it where this the dark line is. Now see this. This is what exactly is. So here its behavior is unitary. If you're putting 0, so what is expected from the operation is output is also 0, like a linear operator. But if you are using one NOT gate, then it is not linear, right? So this gate is not actually your unitary gate because the output is 1 is always. Now I'm not using here this matrix. So I'm using here H gate and one control gate. So 2 qubits, simple. Because today I discuss about the control gate. So control gate, what exactly? I'm just basic, I'm a phenomenon. If because here you are using the 2 qubits, so like how many combinations? 0, 0, 0, 1, 1, 0, and 1, 1, 4 combinations. So what is the control gate? Control gate said that if the first qubit is 0, the rest qubit is unchanged. Okay. If the first qubit is 1, the next qubit will change. So what will change? If it's 0, then it's 1. If it's 1, so it's a 0. Okay. So this is what exactly. Now, third block, first is if you connect with my first slide postulate, the first slide, what exactly? The state space means preparation of your energy. See, this is the first state. Second is, this is operation. One more block is basically here is missing, which is called measurement. Now you are putting one measurement. So many time question asked, so how many measurements is supposed to be? I said you can use one minimum or maximum, depends on how many channels. So how many channel are we using? You have 2 channels, so you can use two measurement. Okay. So here you can register. The C, this is your classical register. All the measurement is basically storing in the register side. Now you can simulate. You can, when you are simulating, see this output, because it's follow the Bell inequality. So the output, I said that the maximum output should be always 1. So 1 means the 100%. That means this is the 50% and this is 50%. Rest 2 qubit is a 0 particularly. Okay. So this is what exactly the basic. Now coming to the again so here. Now we are putting one more hard gate here. If you're putting one more hardware, see this, what is the output? If you see this output, but again, this is a equiprobable. It's validate the Bell inequality. I said, nah, equiprobable means either 50-50 plus or 25-25-25. Again, you are adding this, all this percentage, it's a 1 particularly or 100%. Now I'm adding one more hard gate. Let's go for this. If I'm adding one more hard gate, then what is the output? Well, again, its output is what exactly is 50% and 50%. Now see this, what exactly will change. If I'm adding one more hard gate here, now what is the output? See this. See this output. Is it equiprobable? No. Why? But it's entangled. We can see this. This is still it's entangled. But why? What exactly has happened? In a single qubits and single states, you're getting the entire output. But still they are entangled particularly. So this diagram is basically, if you're talking about this diagram, race 3 diagram is basically validate the Bell inequality. This diagram is not validated the Bell inequality. This is basically diagram with the violation of the Bell inequality. This particular the operations. Now next job is when you prepared your quantum operation, validate all these things. Now you have to just click on, see this right side, there is a one bottom, the class quantum to classical. You just click it quantum to classical. When you're clicking, what happens? See this. There is a one there is a one two more block suddenly came. One is the cost function, another is the optimizer. As I said, that's my control gate is after operation measurement, you can add cost function. Now you have to click in here. Right now, there is no any cost function you mentioned. You can just type, there is many cost function is there on GitHub. You just copy and paste here and okay. Okay. And here you have to click the cost optimizer. Now here inbuilt optimizer is Nadella, Powell, and Cobble, but my suggestion is to don't use this optimizer. You can start your work on from this one, but now your job is to, because your work is to develop a metallistic optimizer, quantum inspired based metallistic. So you have to develop today itself for the quantum inspired based. So how to develop? Because there is a already inbuilt, you cannot change here. So you will change how? So you can change to from this exports. You just click on, because you have to download all the Python code. See, automatically There was one story. I mean, when I was attended the first interview on the South Korea, and the Korean professor were asking about that because I'm an old school guy. I started MATLAB and all. I never used the Python and so because this all the simulator is basically to related to the Python. Should we know about the Python or that not? So my professor asked the question, do you know Python or not? Last question. The story is very always I'm saying, and that was a very beautiful story. I mean, said if I said like honesty, I said no, sir, because I never used the Python at that time. 2022 till 22, I never used the Python because uh, in India is either you can use the MATLAB or anything. I use the MATLAB. I develop all the my techniques through the MATLAB, but simulator because of that reason I never use the simulator also. So in South Korea, first time I used the QPS, AWS, Qiskit and all. But question was the same thing: is how to develop a quantum algorithm of the metaheuristic. There is no any block, there is no any something. So you should be aware about the Python code and all. So obviously, we are Indian. We know that find out the way reverse engineering all. But some of my collaborator is from UK. They suggested, they told Kumar, you can just explore the QPS and start working on this. So I started the QPS, and this is the what exactly the QPS where I start and where actually right now I develop a quantum algorithm. I convert all my MATLAB code into the Python. I tested my algorithm on OR tool. So I always, when I come back to India, Qiskit is one is obviously globally there people are using. So I started pitching on talking about that. You can explore, please explore the QPS also because as a zero to whatever I'm right now working, because of that simulator, I learned something. So you just explore here, just click to explore, and there is automatically they will give the Python code, whatever you develop the circuitry here, and see this because you did not mention any cost function. So here is the cost function is zero. So I said that you can just copy and paste here the cost function, and inbuilt is here is a Powell. So now your job is to like again the many GSA GSO code is there in classically people. It's not an old new version. You can just paste here instead of the Powell, and then you can run this the code on the Jupyter notebook, and you can see this. Now, why other is very important other things because you see this all the simulator, mini simulator here is there. Like this is Qiskit one. Now, if somebody are using the AWS bracket, you just click AWS, automatically they will convert the Python code in the AWS form like this. See this. Now you somebody are using the Microsoft, you can just click on, automatically they will give this Python code based on this. So now why is this is very important, I'm saying if you want to work on any of the simulator, you just start work from the QPS, download this Python code as per your Amazon and something, whatever that. See this, there is all this simulators fetching is there. You can just click on fetch this and that's. But inbuilt, obviously it's a Qiskit 01 something like that. So you have to test because the India and globally always the Qiskit. So whatever the programming you're supposed to be working on any of the simulator, validate on Qiskit also. This is what exactly my suggestion is. Also, so this is the one way is to apply. Now, if somebody are interested or no, sir, I don't want to bother about the algorithm. I will start my encoding or decoding. So what exactly my lecture is, the next lecture is on the encoding and decoding. So at that time, I will show you the encoder and decoder side. So please start explore here. So here I will stop my talk. And if you have any question regarding the right now, or maybe we'll end of this talk also, we can conclude or we can discuss all this, uh, both the my talk. Or if anybody will are interested to work or to ask the question, please ask me. Thank you.
Thank you, Dr. Gautam, for the engaging and Gautam will continue with session 4 immediately thereafter. Both sessions will be shared at around 8:40.
Ms. Kanika, please repeat again. Your voice is not audible.
The next session is, can you just repeat?
So I was saying that there's a short break for 5 minutes. Then
Okay,
thereafter we'll start session four.
okay, okay. Thank you. And then all the
Yes.
questionnaires and all will discuss on the last.
Okay, sir.
Yeah. Feedback link for both the sessions will be provided at 8:45 p.m. approx.
I kindly request all the participants to please remain connected as Dr. Gautam will continue with session 4 immediately after that. And the feedback links for both sessions will be shared at around 8:45 p.m. Thank you.
Good evening, everyone. I welcome you all again in this session. Now we start session 4. I welcome Dr. Gautam again. Sir, over to you.
Yeah, yeah. Thank you so much. Just wait, I'm saving. So visible?
Yes, sir.
Okay. Thank you so much. So, as I continue, so my second talk is basically talking about the cryptography side post quantum era, and it's basically the more application is uh, communication, particularly. So, as I said that last year we my team is selected by so some cyber challenge, and quantum protocols particularly. So now the many time many people are confused about that in the cryptography, what exactly protocol and what is basically planning to start. So like somebody is like like you can start a PQC or somehow is the quantum era based. So my suggestion is to explore first classical, whether it will be the what is actually the drawback of a RSA, what is the drawback of a ECC also somehow true. And then you have to explore the NIST based NIST NIST. And NIST has already the 5 protocols. So it's the 4 particularly and all. So one protocol is the 2022, that story you heard that the some attacks occurs on the isogeny something like that. But my suggestion is to don't obviously some pro and cons is always in any you can consider the ECC if you consider with lattice based or Kyber, has and anything like that. But see what exactly the pro and what is the in advantages for your use cases particularly. So I started, and when I discussed with my team and all, I said let's start with the some ECC and with any of the NIST protocol. Then I found there is some best I mean saying the best, the USP of isogeny. But it was again I said nah, people somehow is to they're watching what protocol is somehow is to started. And when I started journeys to last year, it's a very beautiful story, something like that. Like when I was giving a presentation on in front of the comedian and all, and this, they just picked the name is isogeny. Oh, okay. That means why you're choosing this isogeny? It's already attacks and all, because people actually understand on knowing about the story, what actually where you are supposed to be fail and what exactly, but they don't know about what exactly the USC of the any of the protocol. So I describe something, no, sir, this is the what exactly reason and all. Then I found something. See, if you want to start any of the protocols, first you have to do the research hardly, whether it be the QKD. See, when I visited last year to Qatar, so I met three type of person. And in Qatar, one is they're working on the QKD, one person they're working on symmetry based, and one person they're working on the asymmetry. Now, as a researcher, as you're working on the cryptography based on what protocol is, because in India, lots of people are working on the QKD side and on already DRDO, IT Madras, many startup, QNO, and QK, qubits, and all various startup are particularly working on the QKD. Now coming to this, the lattice based and NIST. the DRDO scientists, they're working on lattice based. CUNO is working already. They developed some lattice based and all. Now, so my protocol is some hybrid based. So we are not trying to replace anything. We are actually trying to enhancing the existing protocol. So that project is some stage we selected, got the grant, but obviously there's some like uh, something what exactly is missing from my side and something was some committee side. They did not exactly the what exactly I terminologies to use particularly. So maybe sometimes you receive a rejections also. But the why I'm supposed to be saying the story today, because and after that I never stopped. I submitted to some this proposal to somewhere, and the just I'm sharing this on 13. I have a final pitch on AWS security. So okay, Maiti did rejected this idea in some stages, and but it's not supposed to be somehow you will stop your ideas. Now, obviously, your research is you can know that what exactly the validation and something. So today, when my talk is again, I am more concerned about to start if you want to really use the quantum computing based protocol. So please have to learn the computing side first. And computing, as I said last talk, is quantum gate, quantum control gate particularly. So me and my team is also developed some teleportations based particularly to how the Alice will transmit single qubit to Bob. And Bob has a 2 qubit states. So you have to send when the 1 qubits to the Bob, then how you are supposed to be protect your the information and during the channel. So this conversation is to talking about to protect the secure communication network infrastructure. I mentioned here QKD. Don't please bother about this QKD and all, because many times also some talk utilization of a QKD is very important. But obviously, I am trying to enhancing my technique in some aspect. So one is have to start your work on the identifying which protocol is much better as compared to the other. Don't jump into the hardware side. You have to start to provide the SaaS based solution or VPN servers based solution. Like you have to just banking sector, you just replace the VPN server, or not replacing, you are just incorporating your protocols inside the VPN server. And you have to hand over the data to client before you have to check, capsulate, and recapsulate all the information, and then you have to hand over. So my suggestion is to start explore the ECC, pick any of the NIST protocol. Yeah, I will share the Pavan sir some paper regarding this NIST based. So first you have to read all this protocol. Don't jump into the like, okay, I have to pick on this. If you are a beginner for this area, my suggestion is to first you have to read both the side, classical and quantum cryptography side, and then have to discuss with the or your team member or identifying, and then you can start your work. Okay, if you are not already you chosen some, no sir, I'm working on the lattice space and something, then I'm happy. Okay, you already decided, you can start your work. So what exactly is, see, always just think about whatever the supposed to be like potential of this algorithm should be, it should be always unbreakable. Because right now we don't have a, the story is, I mean, all the technology, we are living in the quantum era, particularly right now. And not now, but maybe next 5 year or coming to 5 year, some attack will come, quantum attack. But you don't know the nature of the quantum attack. We know the side channel attack, we know the mid channel attack, but you don't know the what is the quantum attack of the nature. Like a COVID, when the 2020 the COVID came, everybody was like, okay, what is the COVID in some sense? And suddenly after 2 or 3 months, all are somehow is to like bound in or your hometown or something like, and then the start the find the way solution and all. But now you have to now think about that today itself. How if suppose the quantum attack will come into the picture? I'm not supposed to be bluffing anything like that right now. I also don't know what is the nature of some attacks I am trying to testing like a quantum attacks and all. But I am also trying to find the way how what is the nature of the quantum attacks. Okay, so you have to also think about in that way post quantum era. But before the post quantum era, have to also analyze on this the classical things, what exactly the people are still working on the RSA or ECC and something. And I mentioned that in that slide, the SOAR algorithm. I will suggest to the book always, Nelson and Chang, and they mentioned that SOAR algorithm. Even SOAR has already published the paper. So if you want to start to work on the crypto side, quantum cryptography for the particularly the secure the network, one suggestion is first, classical cryptography. Think about that. At least these two. Second, read the NIST white paper immediately. At least you have to identify this, what exactly the NIST is. What? Suppose your digital signature. I am suggesting today you have to use the hash, only hash. That is sufficient. But please don't consider it. Okay, sir, Kumar Gautam, he said that. No, I said you have to first read the this particular what exactly is NIST white paper, and then you have to match my voice, what exactly today I'm claiming about this particular, and then you can start your journey in something like that. So whatever you are supposed to be choosing, or whether it be the hybrid based post quantum cryptography or purely quantum based cryptography, you have to, before that you have to all your research, something you have to complete your, and then you can, whether it will be take 2 hours, sorry, 2 days, or somehow is 2 months, or somehow is something like that. But identify, before identifying you have to stick on that, because think about that one problem statement is always this, your is attack is the quantum attacks. Okay, so the objective is your work is for first have to develop a quantum secured communication network using the QKD. You have to also study this, because the 70-80% are working, people are working on the QKD side also. And DRDO, today I am sharing the one problem statement of the JCB lab DRDO. They are looking at people who, the best part is right now DRDO, they are interested on the person. Okay, before, I mean, 5 years somehow is to, they are always interested on the organization. But now the idea is somehow is to interested about to person also. If you are really happy working on the quantum cryptography using the QRNG, something enhances the cipher using the some AI or something like that. If you are utilizing these all the techniques for that, definitely DRDO will entertain you also in this particularly. Second is topology, like network, because right now we are talking about the how to develop or protect the network, particularly or internet, or somehow is to server based. You have to design some hybrid maze topology, ensure the scalable, reliance, and efficient the key distribution across the geographically distributed nodes. So node to node, like this is what exactly we are talking about, the optical based, right? And QNU has some last year they claim that they are tested up to 500 kilometers, something like that. That is a node to node. But if you are supposed to be increasing the distance of the node, then again it's very difficult to find out the same output. So this what exactly second problem is, second objective is basically it's a problem statement. But the first you have to identify the secure protocol. Second is, if anybody are interested on the hybrid topological network side, you can start. Third, what exactly I'm talking, integrate your QRNG, and very simple. I mean, the QRNG kit is also, there's some lab is there in Delhi, the VIPS, Vivekanand Professional Study, and they have some QRNG kit, and they set up a quantum lab. So if you have a good connection or anything, you can visit, or you can see this, how the QRNG is basically work for this particular, for the strengthening of. So your job is in the, now I'm talking about the research side or somehow to, so please integrate your QRNG to enhance the cyber strengthening, resist the quantum attacks, ensuring that all the compliances FIPS 142 or like a EQD and QKD, sorry. So the last is obviously mitigate all the challenges, signal attenuation, trusted node. As I said that IIT Madras, the Professor Anil Prabhakar sir, he is working on the trusted node. So your job is also to start like a trusted node in layman term, it's a bank manager, like that. Like when you are going to the bank, so who is your trusted party? Trusted party is basically your bank manager. So bank manager is assured that your money is safe in something. Okay, and they will give your any numbers, unique numbers, every account, something like that. Okay, so same thing in node, you have to create, every nodes is sitting some of the virtual bank managers. So is it possible to develop some quantum trusted node, something like quantum gate based particularly? And yes, you can develop. Like simple example, I will share. I will explain the later slide. So last is challenges as to how this mitigate for this space communication particularly. And this is the big challenge. And if you heard the news last year, the IT Delhi tested and for 1 kilometer particularly, and see that 1 kilometer in the air to air in LOS. Okay, it's a eureka like that. But obviously, if you ask to Professor Sankri sir, is it really you are happy or not? Obviously, he said, no, it's not. Because 1 kilometer is very small like that in LOS. If you increase the distance is 1 to 2 now, it will not possible to, they will recover this 8% or 9% what exactly they claim the bit error rate. So what happens suddenly? So in an environment, I mean, see this, the tested on the that day, it's around 2 to 3 time, AM in night. They tested the cloudy, they test the pollution level. Right now, what exactly the Delhi scenario is. Right now, it's not possible to test. I mean, obviously, your photon is interact with the pollutions, the molecules, and then they lost that deoccurrence occurs. So also you have to find out the way to how it's supposed to be create the trusted. So that trusted node is basically take care of your all the photons and something like that. So the key, what exactly? So start from the 84, the first BB84 protocols. So I'm just here, you can just note down something if you are interested on this one. Please connect with this, the chronology. As I said that last slide, last talk, I mean, the first talk was also, I was talking about the quantum chronology. Here I'm talking about some protocols based chronology. The first 84, the paper is already, the first paper you have to download this ABB84 protocols, and then E19 protocols is basically, and then 2004, so ID Quantum, they develop some commercial QKD. Now the many company and startup is already, they develop a commercial QKD. So you can QTool and many other things. You can also planning to develop some commercial based QKD, and either you can connect with the Keysight, Infinity Point, VIB. These are the company where. And then 27, the DIPRA is basically they have started the working on the quantum repeater, but still I'm saying that there is no any quantum repeaters yet to be. So this is an open problem, and Professor Urvashi Sinha from the RRI, she is working on this problem statement on the quantum repeaters or something. And 17, this China is first time they basically announced that we are tested from the Beijing to Paris, something like the QKD. It's all are the gimmick. Still there is many milliseconds satellite QKD and so on. Now the 2020 is time to the military and post-quantum era. So from the 2020 plus is all like last year, or when the National Quantum Mission announced 2023, I mean, if you just connect with all the state, all the nation who actually already incorporate the one objective should be develop a post-quantum era protocols for the secure communication also. So this is the what exactly the chronology, and you can start like a picking out this particular things. So traditionally, as I said, that's all this public Alice will send like traditional method is what exactly is. There is one private key, and it is not so much secure as obviously. So like either you can use the RSA, DHS, ECC based on something like that, and then you can say. Now there is the one method there people are start the working on the subfractal chaos method or something like that, and then they are trying to enhancing the ECC or some. I am using the fractal chaos theory, and then I incorporate this ECC with the fractal and tested on the SOAR algorithm. So because of that reason, I said that you have to also check what is the SOAR algorithm and how the SOAR algorithm is breakable for the how many qubits and something like that. And now coming to the enhancing, what is exactly the now, as I said that we are working on the quantum channel. So you are the basically the person to protect this what exactly the Alice will send. So your job is to secure your information or digital data on from the server. So if this Alice will send the single qubits information to the Bob, and you are creating one gate model, control gate, like a simple. So how the control gate work? I just said that the first qubit is 0. So rest qubit will not change. If first qubit is 1, rest all the qubits will change like a 0 to 1 or 1 to 0. So if Alice will send the single qubit cat 0 plus cat 1 to send the Bob, and Bob has 2 qubits like a cat 0 0 plus cat 0 1. Suppose it's just I'm just setting one example. So first Alice and Bob are entangled. So if you are entangling with the Bob, so what exactly? The first qubit, any single qubit will entangle with the 2 qubits. So what is the output? I said that it's a tensor product. So if the cat 0 tensor with cat 0 0, what is the output? Cat 0 0 0. So that is basically it's converted into 3 qubits. And now the Alice will send the 3 qubit. I means this is the what exactly? But before sending the complete sending, you have it, your bank manager means trusted node, that trusted party, they will decide to secure. Right now, you have a supposed you have a combination of like that 0, 0, 0, 3 qubits plus 1, 0, 0. If just considered, if you have a combination of these two. Now, trusted node, you have developed a control gate. Already, I last talk, I mentioned that how to develop a control gate. Now, control gate, what exactly they will? They will identify either 2 qubit space or 3 qubit space. What exactly this means? The first qubit is basically zero. His control gate said that rest qubit or adjacent qubit will not change. So what is the output? The first is 0, 0, 0. So the output is again the same 0, 0, 0. Now the second input, what is 1, 0, 0. So control gate said that if first qubit is 1, the adjacent qubit will change. So what is the output of? So now the output is 1, 1, 0 because the first qubit is 1. So you can write your algorithm in your way. Like you can also write if you're using 3 qubits. So what is the algorithm will change? If the first qubit is 1, rest all the qubit will change. Okay. So now the input is 1, 0, 0. So the output is what exactly? 1, 1, 1. It's like that. It's very simple. So you just try, you have to try this control gate single 2 qubits based or 3 qubit based initially. Then you can add more gates like a control to phase, control to X. You have to increase the number of qubits. You have to increase the operation also. Now that then you have to send the Bob. Bob can obviously just decode, recapitulate the information. And what is the base part? Because the hackers can know that this information is single qubit. Suppose somebody is like, okay, Alice has a single qubit, but now you are changing the first entangling. So you before sending, you have to convert the 3 qubits, and also you have to pass through the quantum system. So the gate-based quantum system, they can actually convert your or encode or encrypt your actual 3 qubit informations entanglement. They're already secured because entanglement. But again, I'm saying that the hackers is also quantum prone. I mean, they are expert in. So they know that the entanglement phenomena. But if you are supposed to be secure through the gate-based model protocols, then it is very difficult to it will decode on something like that. So before is that have to enhancing to understand this what is the BB8 for something state. Then you have to understand all the Q encoding rules, like I mentioned here the encoding rules, and somehow then you have to also splitting the attacks, either photons resistance based. Recently I'm working on right now all the photon generation is something like SPDC. So my project is basically on maybe they selected me in my project. So this is the two-way of project. One is the I will develop a quantum radar. Second, also we have to develop a graphene quantum dot for photon generation. And SSPL lab, I am just sharing one another problems here. SSPL lab is right now looking at 1550 nanometer photon generation. Right now, in the market is around 850. If somebody are somehow interested on some photon generation and something, say they have idea about this the hardware side, please be connect with me, and obviously I will connect to this SSPL lab also to start the work on. Or you can connect with my project also to how to develop or for the 1550 to achieve the 1550 nanometer for by photon generation. Because see this, if you increase the LOS from one, because I claim that I will test in LOS line of sight for air to air is 10 kilometer. So IT Delhi tested just 1 kilometer. If I increase the same photonics based something SPDC, definitely it will fail. It's not possible to like the quantum radar will work. So first job is to whatever you are using the hardware side of photon generation, that should be like in high intensity, should be wavelength is at least 1550. Then it will achieve your what exactly we are claiming to 10 kilometer, and surface to surface we are putting 50 kilometer. Why supposed to 50? 50 is very less because China is last year they claimed that we'll develop a radar which is covered 5,000 kilometers. See this, China to distance India is not 5,000. It covered, it means like 5,000 means to cover all the Indian Ocean also. So think about that also. This is just a gimmick, but it's a gimmick in these days. But they are already working on a very high prawn. You see the number is till now China invested 25 billion USD. India is interested about to 5, or maybe now it's like now RDI is something, but RDI is a means diverted or something. There is all the funding, but I'm talking about the only quantum side particularly. But India is now slowly they increase emphasize to connect or to identify the people, identify the institution. They can start this. So I am here sharing the some methods also you can implement. I am sharing the some problem statement also. I am sharing here where you are supposed to be direct to connect or contact to your problem statement to identify this one. So what exactly the threat landscape is? Quantum computing is obviously its advanced version of the source and global algorithm threaten a traditional cryptography like RSA ACC by enabling the efficient key cracking one. Second is obviously is the military and government because right now I'm working on the some defense applications is also. So I'm very happy to invite the people who can supposed to be work on the for the future proofing of the solution to protect sensitive data from the so we have to like this is a very it's not my quote, it's a very renowned quote on the given the harvest today now the decrypt later it's like that. So we are like खेती आज करेंगे तभी तो फसल will get somehow. So think about today, so how to tackle this attacks, not like a covid and somehow is to have to think about today, have to develop the some quantum protocols who will protect, I mean later something like that. So now advantages of the why is supposed to be the QKD. You can explore your QKD because there is a leverage of the quantum mechanism with the hardware side particularly for all the ITS system, ensuring your key and securities are endeavor. So due to the no cloning theorem particularly, you know that the no cloning theorem, so all the quantum states are basically it's not like a clone either. After the decoherence, you will not possible to extract the same information for the same quantum state particularly. So another is the combined OTP is a very famous and recently I will share the one paper also OTP encryption based. If you are, anybody are interested on this side, please just ping me. Also, I will share the exact problem statement. So recently the JCB is looking, is it possible to work on under this the Shannon Shannon entropy because you know when you are working on the quantum communication, Shannon entropy failed. Okay, so you can start the working on the some von Neumann and all. But JCB is now particularly they are looking the person who can start a work on the under the which cell, how much the Shannon condition supposed to be supported by the this method. So the one paper they're using the OTP encryption method, and so they are basically some HAV to like this is some South Korean people and they are some claiming about the 8,000 kilometer QKD network some that is basically node to node. Again, I'm saying that they are not using the repeaters, they are not using any trusted node something. So they are establishing the each node for the each 1 kilometer and something like that. And there's some demonstrated feasibility possibility or not. So this is my proposed block diagram. You can please also connect with this and it is already patentable. So I'm not bothering about anything somehow is to. So this block diagram is basically you can start your work. Like a classical bit is always like my voice signals. So how your voice signal or text signals to cope with the first you have to convert the state preparation. Like obviously in a qubit, like in classical communication, you know that your voice signal is converted into the electric signal and then electric signal, then you convert the sampling to quantization, then encoding, then your classical signal or like a continuous signal to discrete digital signal, and then you have to send the same in digital signal either 0 and 1. Here you have to just convert our classical data to put into the state means we cat 0 and something like. And then you have to who will carry these states, the photons, so you incorporate. So I'm using here the EPR generator, and that generator is basically built by graphene quantum dots. I'm not using the SPDC particularly. Most of the people are working with this because it's a project, new innovations, how it's supposed to be claiming and somehow to. So we develop something like then uh, have to obviously when you are prepare your states, the photon is ready to travel. So no, you have to encode first quantum error uh, based encoding and then pass through the quantum gate. See, if you want to work on the quantum based protocols, have to understand about the quantum gate. And gate means the same gate. What exactly is the unitary gate? Right. So I am just here. I'm explaining the quantum gate means the same, the control gate and something. And then you have to pass through the channel. And I mentioned here the same the Schrodinger channel. You can use the same Schrodinger channel application and build this something like that. And then measuring this qubit module. And now receiver end, you can again you have to check whether the error corrections optimization. Here I'm incorporating some AI ML error correction method also. This is my patentable a method. So I'm because some problem statement is also there, like is it possible to AI ML based application incorporate with the QRNG or QTD? So I started research in some 2 years before, and then I found okay, we can incorporate something. Yeah, I used here the basically RL reinforcement learning for error corrections, more optimized, and then the decoding is the same and the input. So this is the what overall the block diagram. If you want to also start work on this, the concept to enhancing the cyber security to protocol. So where you are can actually build the protocols is here the channel side. So I already built some MBPS stage with ECC based plus isogeny. So if anybody are interested or is working on the Kyber or has for teleportations particularly, so please you can also join and work on this particularly this domain also. So this is open problem, and so this talk is also like a aggregated on this cryptography protocol. But I'm a quantum guy. I'm a quantum computing guy. I am always looking some gate-based model and something. I'm insisting to people to please learn the quantum gate and apply the quantum, because in the future is a quantum computer somehow is to come to the picture. Definitely you can know about this utilize, and don't try to match the property of the quantum, something like that. So start with the 2 qubits or 2 qubits. Forget about the 10 to 15 or 200 or 1000. Forget about the objective of the right now. Think about the 2 qubits or 3 qubits gate and build this and secure the channels, apply the control gate and start working. Replace this right now. Don't bother about the ML side. Later stage, you can start the working how the ML will be help your entire cyber side, sorry, cipher side and some enhancing the key or not. Right now, you have to just build simple protocols, gate-based protocols to enhancing the security for the future program. Okay, so this is the architect. I said my second goal and objective is to propose network architecture. So people are already using some Maze and Star, but I emphasize on hybrid based Maze Star topology to balancing the obviously three conditions is always important, and which is basically I said that this is a proposed model of the term. I said that every node is you are putting the place one bank manager, which is exactly trusted node. Is the Kumari is a trusted node? You can start the work with the trusted node. So what exactly the start topology use the central hub with QKD device. See this. This is the basic installation where you are supposed to be install this QKD hub and device as a trusted node and for the region of the zones and connecting the endpoint via the point-to-point QKD. Like see this. I am putting here this. This is the one network structure, QKD network structure. This is the another QKD protocol, and we are basically placing the information QKD and also. So this is what exactly this is the whole the structure of this. So you had the classical connection and here is the quantum protocol. So you can also start the working on this if anybody are supposed to be building this topology based protocols to enhancing and all. Second is the mesh is interconnection with the each hub. Like this is the hub. Each hub optical fibers are either satellite. So obviously now the next challenge is always is satellite communication. QKD link the long distance and key relay redundancy ensuring against the reliance of the against all the failure. So this is my proposed architecture or this model. So please also have to start your work on this architect model also. So key performance is always think about the one is the its key rate is 100 kb. There is a fiber based and up to 10 kb, particularly in the satellite. So second is distance from the 1000 kb. This is the one terrestrial is basically it's as per the NQM objective is have to test on the 1000 for optical, 1000 for satellite. But my request is check on that first 1 to 5, then 10, then satellite to 50 kilometer is enough. If you are supposed to build a 50-kilometer base, and that is also sufficient to work on this. Then is basically security and secure the information analytically. Then you can also compare with all this BB84 other they use the E19 MDI QKD and have to please comparison also to your gate-based model protocols, and then you have to stick on this. This is my best post-quantum era protocols, and so to secure the post-quantum world also. What exactly the achievement is the key innovation is obviously I said that China is many times is making on the satellite demonstration on QKD. So please just see the story and learn the story. Listen the story and don't forget about what exactly they are planning on. Right now, you have to stick on your goal and objective. You have to test and validate for the particular what exactly you are using for either 5 to 10 or later you can increase the 1000 plus and all. integrate the QKD chip compact. There is some company. I will invite. I will share the name also. You can anytime you can invite for the demonstrations. There is one company is my partner also. So if you want to somebody are interested on how it looks like, you can invite next time to as a for a demonstration of the table develop because recently they delivered the some QKD device to JCB also particularly. So you can also invite these a startup for to see this how this the QKD will work and also. Then the post-quantum integrations, obviously, it's a QKD being the combined the post-quantum classical quantum. What exactly I said that start the think about the hybrid base, and I'm giving it today as suggestions to start the ECC with the isogeny, ECC with the has one, to start learn some fractal chaos theory. Because see, there is a secret key and the public key. If your secret key is state is always changed somehow, right? Not the t is equal to this point, t2 is equal to some j. Because the quantum state is it's not like an absolute. It will change and your secret key is very difficult like the hackers will not identify. So that is the beauty of the fractal chaos theory. You can just type in chaos engines book. There is very book I don't forget. I don't remember right now the name, but I will share the link also that also on this side. So my suggestion start the working on the ECC with any of the any space protocol. If you want to work on the digital signature, my sense just stick on has. There is sufficient. You will build this, and then last is obviously the momentum is it's not like you can just claim I will replace. If you are supposed to be said I will replace, nobody entertain you. You can say this I will enhance, strengthening of the existing protocols. The world will entertain you because we are not supposed to do like right now, not beyond the nest. I have to think about that because nest is already there, set up in something. Okay, this when probably the next year or maybe in 2 years, if India will announce some protocol, something in global level, then you can also come and work with this. So this is what exactly the next leap is particularly. So expected outcome, think about what exactly this outcome means, this talk or something. One is always unconditional security. Client will not bothering about what technology and support. They are just bothering about what exactly you are providing the all the attacks, including quantum infrastructure. Second is scale, whether you are topology or somehow to network, you are really expensive to via the satellite and optical, both the side you are scale. And obviously it should be interconnection of the maze and trusted node. But exactly the one problem statement I'm not talking about the right node repeaters, but I am talking about the trusted node. You can build the trusted node, which is basically the gate based model. And efficiency is the SDN and KMS optimizer is key rate is right now. This is think about that. Is it possible to change on something like the MBPS and something like compliances obviously meet this criteria standardization the interpolation. You have to just this information is mentioned in the NIST uh, white paper that I will share and you can read and that you can understand what exactly the science is. So how the concept in the entanglement, as I said that this is a signaler, as the signal is basically, and this is the idler is somehow the one signal is cat zero, idler is like, if you're generating the entangle means this one story is again, I remember suddenly. So when I presented first time in the Navy and somehow is true, and one of the person is totally classical based, they had don't idea about the entanglement and all. So they asked what is entanglement? What exactly? How is it possible to entangle photon pair? Photons pair means it's a clone sister, and one sister is sitting in your home and another is traveling suddenly, and they she will eat anything like that. So automatically whatever they will eat or something, that automatically the first sister automatically they understand or they can automatically they get the information because both are entangled. Whatever the state will change, the idler or somehow the another sister, first sister will also state it. So it's like up and spin and down spin. So I was describing or explaining about this phenomenon, entanglement photon phenomena in layman term, and then thanks to at least they can connect the stories. And I always say, sir, have you remembered the Sita Gita movie? And then, oh, okay, yes, I remember the Sita Gita movie. And then, so, okay, this is exactly the entanglement photon is somehow traveling. So nothing will return. If you are sending the, suppose the photons, the one photon is sitting in the idler side, one photon start the traveling. So in classical radar or any application, suppose nothing, its electromagnetic will return. So power is very high. Here, nothing will return. Photons are continuously traveling. So what is ideally, what is the power? It's a zeros. So if you're supposed to develop any device, it's a zero power, it's the best. But ideally, is it possible? No. It's very difficult to this. All our quantum phenomena is really, it's very beautiful. When you start working on the real time application, then your real challenges start. But that is the beauty of the what exactly you start the working. Okay, this should be okay. Possibly it should be all the quantum gates should be unitary. But when I start the in real time, it's a violation of the unitary. Then what exactly? Start the searching how to maintain the unitary. Now, when started developing the radar, I found, it's a very beauty. We can develop generation the photons. It's a zero power. I mean, the comparison is best. But when you start to real time, how is it possible? And obviously, photon will travel, photon will hit the another states. They will change the state. Maybe there is no target, but still they will hit to any disturbance, like any udens, any bird and something. But photon will change the state, and idler will again. Okay, they can measure the information, but that was not target. Something like. So you have to think about this concept first to what is basically entanglement, particularly. As I said, now first you have to entangle with the Alice to Bob, and then you can start write the protocols. Okay, so this is what exactly the concept. If the signaler has measured the zero, idler is collapse to zero. If the signaler is measure one, idler is. This is what exactly the how you are supposed to be start the real time work and something like that. Then I start the flow chart. This I just explaining a small to like if suppose the this diagram is correct. Here we can generate the photon sphere. Like people are using SPDC, I'm using the quantum dots. So the one photon started traveling for the here, this side, one photon is sitting here, written, right? And the photon is like one photon is targeted. Now your job is here, this arrow. Your job is to protect, develop this security size, particularly protocols. And then whenever the interaction hit the target, idler will change, store the information in the lab and idler photon. And then you can detect the quantum detectors, particularly like what exactly the receiver is. Here the Bob is basically counting the your all the state changes. But I am trying to also find out the way how supposed to be photon comparison or analysis, how the exponentially compensation, how the in signal to noise rejections. This is one is the quantum radar for the stealth. But it's not only the stealth also, we can also identify the more application in different. So Navy application is again it's very difficult because the Navy SIP installation of the SIP is very this SIP is not stable. It's not like a, but if you are supposed to be establishing on the any application in like an army and something like that, it's much better as compared to what exactly. But what we are not bothering about because it's the use cases. If suppose the recently, I mean last month, Navy announced that one challenges. Is it possible to develop a cyber protocols for securing the channels also? The last date is also, I think, 10. That I'll also share to uh, Pavan sir. If anybody are interested or a student are supposed to be ready to, they can also be participate on this one. So this is what exactly the idea. And then I develop what exactly the entangled photons and somehow is to. I said that because the Alice will generate this entangled, they will send this. So this through that. So this is my state generation 1 by root 2. This signaler to idle and the signaler to idle. This is what exactly the state generation. This is basically what exactly entangled photon. Both are if you are single qubits. So cat 0 tensor with cat 0, cat 1 tensor with cat 1. So this is the phase shift of the one photons. Now the target interaction when their interaction, suppose, so there is a one phase is automatically change. If entangle evolve after the evolution, if the phase is occurs here, then you can identify there is a some error in this side. So how we are supposed to be this particular that evolutions is basically the pick the reflections and they will basically identify the states how much information based on the phase shift of the motions. So then the third step is basically how the idler stays in lab particular what the environment return. There is no any return, but in terminology is particularly in the phase term, possibly the gaining the relative phase. And then idler stay in the lab particularly they can interact with the environment and return, possibly gaining the real. So if there is a interaction, no target means separable. Separable means you can just I will explain in the very simple way. There is a two type of system. One is a separable, another is a non-separable. Like before this talk, in the 6 o'clock, see that before 6, you all are separable system. Everybody has a own Hamiltonian. But when the talk started, I am just considering all the people. Basically, the Hamiltonian is just one Hilbert space, and they are interacting with the my. because I'm not supposed to be the person who are basically the separable. So when you're interacting with my energy, you are not separable now. You are a non-separable system. So the tensing, the your Hamiltonian tensor with the my Hamiltonian, and also there is one another terminology. The one is potential. So what exactly we are talking here? I am sharing my energy or my thought process through my energy, which is called potentials. Okay, and you are listening. Your thought process is something you're based on your potentials particularly. So always there is, if overall, if what is the potential of overall system like me and you, it's a h1 tensor h2 plus v12. This is h1 is your Hamiltonian and h2 is my Hamiltonian, and they are interact with the tensoring with the some potential also. So if there is no target, I said that if it is a hypothesis, if there is no target, so it was like a psi naught. Here I'm talking the psi naught. Psi naught is why supposed to be, because I am always think about when your unitary is supposed to be interact, or your qubit interact with your environment, it loss your decurrence occurs. Now it is not pure state, it's a mixed state, because now you are not pure because you are interacting with the Kumar Gautam. Now you are a mixed state. If I am trying to write the equation, now we are not supposed to be considered you are a unitary. Now I am writing an equation in the form of density matrix. Okay, so because you're matching with my energy, or somehow is to you are now talking about the some mixed state particularly. You are not now pure. Before 6 you are pure supposed to be. So how to extract the hypothesis. So this is hypothesis is like a quantum noise, it's tensing with the idler, and the target reflection is supposed to be entangled with the phase. If there is a phase occurs, then this is the what exactly hypothesis, and particularly if there is a no phase, then it's very easy. So based on this hypothesis, I started like find out the way to how to actually build this the quantum phenomena in the radar applications. And second, the major application, which protocol is basically. So I already, my team has developed some hybrid base, but I'm looking a more opportunity or more viability on this. If anybody are somehow to develop some more application based on something on that, I always open to discuss with this member. So this is my patent is already. Now challenging is this on the obviously the fiber side is right now the 100 to 2 kilometers. This is one, and mitigation is SETCOM is long distance communication. You need to trusted rely on the material. Now your job is to develop a trusted node, which is basically gate-based model to using the any of the protocol. Device cost is again, I'm saying no, this is a high cost. Now you have to, but don't bother, have to adopt some solution, give the solution QoS based basically when SaaS based. Right now, don't bother about the hardware side, start the work on the VPN server based, and to discuss with your use cases like banking and other many industry are basically they are ready for the, just you have to place your solutions in midway and test the capsulate and recapsulate and hand over the client also. And the last is obviously this is very important, and you can participate this National Quantum Mission for in communication. I think you can just, if anybody are working on the cryptography side or communication side, please have to visit T-Hub Quantum Communication. Many updates or many things are going on, and please just, and if you want to work on quantum computing side, please visit on Quantum Computing Hub ISC Bangalore. So these two are, or interested on the material side, IT Delhi, and if you are interested on sensing side like NB atom, NMR, a magnetometer, something like that, or biosensors, please have to visit IIT Bombay Thematic Hub. So these are the basically the work going on. And really, if you're interested on the QK radar side or purely the transportation side is somehow to, please connect with the E-Green Quanta or QS Kumar Gautam, it is like that. So concluding here, I'm okay. I will show some a small demonstration also. So this is right now the true urgency of the mitigations or migration of the quantum computing threatened currently, and most of the agencies and have to approach to right person, right way. Definitely will get. And next job is the adaptation of the IoT. So one of my Qatar guy, there's very soon they will share the problem statement. How is supposed to be provide a solution or protect the digital signatures through the cloud IoT based. So if anybody are supposed to be working on the IoT, please come as a consortium based and feasibility of the IoT with the lattice based scheme with some good performance already there in the paper. You can search it. So the use cases is basically digital signature operations, bottleneck of the protocols. And if you want to develop some hardware side, sorry, software side, so please have to software to tune and protocols adjustment of the all this VPN server based and to provide a product of this. So this is the what exactly the future of PQC and what feasibility, what optimizer you are using. Obviously, the same quantum optimizer you can apply on where, and then your next uh, job is to PQC merge with the IoT readiness for the quantum era, particularly. So thank you so much, and I'm just again the um, coming to this. Okay, so this is what exactly it's a free. Many people were asking about this. It's a free. Right now it's a free, and you can access this QPS. No charges and something. When it will come, don't bother about right now. Okay, you can start. So now coming to this, like initially I said that this is it looks like that something. It looks like that. Okay, so. Now in next job is I mean previous talk is I said if you somebody was interested on optimizer just click it here, okay, and then I already explained. Now next is you have to click on encoder and decoder because now you have to build a algorithm. So how you can build an algorithm something. So like you can I just use same circuit what exactly I develop. So here encoder and here decoder. Your input is something I already explained this. Just a minute. Just connect with this block diagram once again and then I'll explain. Please. This is the block diagram. It's like classic input, state preparation. Then you have to incorporate the gate model, send the channel, measuring the modules. Again, the receiving ML, forget about the ML right now, then decode and then classical. Now commit with this. You just see this block diagram and see this. Now the state preparation is like that. State preparation is here. Okay, you incorporate your input here, encode it, just click here. If you're clicking, there is a no any Python code. Now your job is like what encryptions are trying to use. So I said many times, there is a GitHub. You just download any of the encryption method. Already I'm suggesting to gate-based model. You can build that one, but before that already many existing. Try to first existing. The people are what exactly you just copy and paste here. Okay, the same quantum operation you can use, and the decoding side here. Okay, or you can paste here and then you can run. But if you want to build something your own way for decoding, again you have to go and export here. And if you are trying to exporting, see this is the what exactly your encryptions. Here you can just here you require them. Okay, so you have to just copy and paste here in coding part, and then you have to build this because this gates is already you are building this register is two and classical register because two I used two measurement part and then adding this some more register and this is your gate model. You can remove and add some gates also and then compile it and this. So this is what this is encoder, this is your decoder. So encoder is one single qubits, your encode here, and here you can actually incorporate your trusted node algorithms, and then you can inform this decoder part particularly, and then customer, obviously the customer recapitulations particularly. So custom decoder, particularly how to recapitulate. Encapsulate means basically how to encryptions with the any of the application gate-based model, then recapitulation, then you can just merge here and finally you can run. So you can download and paste here and apply this method to and test it. So this is what exactly is the for the encoder on decoder side. This is for your optimizer side, and this is auto run is simple for like 3 qubits in particularly. So one more thing, just I expanded. Now this you can see this is the 3 qubits, and I'm adding here one more Hadmard gate. So if you are simply will ask why only Hadmard gate is not possible. Okay, so I said that now like there is a separable and non-separable system. Separable means all the there is no interaction picture come. Like interaction means there is no any like interaction between Kumar Gautam and you people. Okay, so the Hadamard gate is applicable only for the separable. The Hamiltonian interacting with this, the tensoring with the another Hamiltonian, simple. So when the interaction picture came, Hadamard gate failed. In 2015 paper, I mentioned that, and you can visit that paper also. When the interaction picture came, the H gate is not, but H gate is a universal gate, but H gate is universal for the ideal only. So for the initialization, I am trying to use the H gate here. For the initialization, I'm use for the initial. I think you can replace also, you can add or remove based on that. Now I said that how to uh, basically minimize the 3 qubits. So here one circuit is swap circuit. So when I'm using swap gate here, please see that when you are using the swap gate, now there is no use of this one. Okay, because you are swapping from this input, or maybe I am supposed to be using here, suppose, forget about this part. If first operation is occurs, after this output here, it swapped to the this channel, okay, here. So there is no any connections. Now this Hadamard is like invalid, okay, because you are swapping your input, your output from second channel. So initially you initialize 3 qubits, 0, 0, 0, Q1, Q2, Q3, or Q0, Q1, Q3. But after in mid, this is called partial measurement. This is called full measurement. Partial measurement means what exactly? You are minimizing the qubits. My significant slide you just remember. I said that, is it possible to build low power dissipated gate with a minimum qubit? This is the way how to minimize the qubit. You can use the swap circuit and minimize the qubits. Now how many qubits are basically using? 2 qubits. How? Because we are swapping here in between. Now 3 to 2. Right? The same thing you can use the 5 qubits to 3 qubits. So this is the way you can start your work on the swap circuit. But have to remember, inside the swap circuit is itself have already one quantum circuit operations. So it's not possible to increase the 15 swap circuit. No, have to use smartly where to minimize and how to minimize. IonQ is one company, they minimize 80 to some 20. You can search. Okay, 80 to 20. I minimize 5 to 3. That was the published. And recently, my work is on under review. Then I use an NVIDIA platform, and I minimize 25 to 10 qubits. Okay, so I used 5 swap circuit. Okay, so you can start your work smartly. It's not like every time you can use a swap circuit, and then you will face the some difficulties and all. So smartly, you can build uh, your quantum operation using the quantum swap circuit particularly, and then you can start your work. So this is my talk. Now I am ready to like any questions from your side, and will give you. Thank you so much.
Participants, if you have any question, ask them.
Hello. Good evening, sir. Pavan, sir.
Yes, sir.
There is no question, sir. This is really very informative session.
Thank you, sir. Thank
Thank
you.
you, sir. Good evening,
Thank
sir.
you so much.
Gautam, sir.
Excuse me, sir. Hello, sir.
Yes, yes.
Yeah,
Listening.
sir, one question. I'm Star from Hyderabad. Sir, why are quantum repeaters essential for building a quantum internet, sir?
Yeah, definitely. Because I said, na, when you're increasing the number of when you increase the distance, then the current recurrence occurs. Okay, so you want to recover your information in the bit way. So like we are proposing the idea right now till 10 kilometer for the LOS, and we are proposing this idea to in the space for 50 kilometer, but 50 kilometer is very small. Your job is supposed to 1000 because the goal is 1000. For the 1000 kilometer, you have to place one each repeaters in either 5 kilometer or 10 kilometer or somehow is two. So the quantum repeaters is basically repeaters in classically, you know that if you are classical communication, you can understand why the repeaters are used. Repeaters are basically recover your original back signals like a 00. If you are disturbed the 00, then repeaters will again recover the same information 00 like that based on the threshold. This is the classical phenomenon. In quantum repeaters, again, they will basically that your photon, they will check how much actually the bit error rate is supposed to be, and they will help to how have to maintain the same the bit error which is basically required for the receiver end. So the IC RRI, the professor Urvashi Sinha, ma'am, she's working on the repeater side. So if you want to really work on interested on this repeater side, please just follow the RRI or Mr. Sinha ma'am papers, and all she is working on all this side, Bangalore.
Okay, sir. Thank you, sir.
Thank you so much, Dr. Kumar Gautam, for such an insightful and thoughtful, provoking session. Your expertise on the quantum technology and its real world applications has truly enriched our understanding of how quantum computing can bring transformative changes to this sector. We are grateful for the time and effort you have invested in sharing your knowledge with us today. The practical insights and innovative ideas you have presented will undoubtedly inspire further exploration and research among all of us. A big thank you to all the participants for your enthusiastic involvement and for staying engaged throughout the session. Your questions and interactions added great value to the discussion. Before we conclude, a gentle reminder to everyone, please fill out the feedback form for the session available in the chat box or WhatsApp group. Your feedback helps us to improve and ensures the success for future sessions. Thank you once again, Dr. Gautam, and participants for making this
Yeah,
session a success. Thank you so much, sir.
thank you so much.
Hello,
Really, that's good.
hello.
Yeah, thank you so much.
Thank you, sir.
Sir,
Yes,
Gautam
yes,
sir.
yes, ma'am.
Sir, actually, I worked on classical cryptography. My research area was also on classical cryptography. And now
Yes,
I
yes.
want to switch for quantum computing and all. So, how to start, or that's what my question, sir.
Yeah, sure. I mentioned that you're supposed to be you are working on the classical cryptography, either ECC or RSA. So now you have to find out. I will share the one white paper of the NIST. Okay, so where the
Okay.
all the quantum protocols. Either you can also search in a Google the NIST quantum protocols. Okay, so first you have to explore this one. One book always I am suggesting to under Nelson and Choi, Quantum Computation and Quantum Informations.
Okay.
Sufficient, that book is sufficient for to jump into the quantum side particularly. So two, one is the NIST, another is to find out the what exactly. And already in during talk I already suggested to please find out the either has or kyber. Most of the people are working on the kyber or lattice based. And two, already you expert in the ECC, please start with the hybrid. Don't jump into directly on the quantum side. Try to find out the how the way to how to merge this the classical cryptography with the quantum side particularly. So this book is sufficient, and I will share some information to Pawan sir, and they will share to all the people who are supposed to be interested on this.
Okay, sir. Okay, thank you.
Thank you so much, sir.
Sir, Gautam sir.
Yeah, yes,
Sir, I am Anna, a PhD scholar from Kerala. Uh,
yes, yes.
sir, now I am working on quantum-inspired optimization algorithm for NP hard problems. I started
Okay.
my research work. Then I have found vehicle routing problem also. And how should I approach that vehicle routing problem? Or can you, like way you have explained about yard optimization, like that way, any other real-time scenarios which you
I
can
am
suggest for
explaining
me?
one use cases. Yes, yes. I'm
Yeah.
just wrap up small. See, have you identified what materialistic optimizer or you are supposed to be like? One. First, you have to like I am suggesting to start find out the one materialistic. quantum inspired based any like metristic optimizer, you have to plan to like first you have to build the actual algorithm, what exactly I mentioned in the PPT, and I will share the PPT also. You can go and connect with this. And
Okay.
I'm setting the applications. Like you can the same optimizer you can apply. I will share the data also for the already I work with the Hyundai and I have some Hyundai data set, and you can work on the routing problem. See, this is the application is the one is the yard or milk industry or Airbus or somehow it's a railway, vehicle routing, electric vehicle. See, application is whatever the you are supposed to be planning to inspired based algorithm you will develop, apply the same application or same algorithm in any of the use cases. So I am
Okay.
saying is like what exactly you need. You need a data now, whether it's the yard based, whether it's the routing problems based or like a vehicle routing. You need a data set only, and then you can work or apply your data set onto. So I shared the first talk is basically to describe whole to how to build without any prior knowledge about the materialistic or something to build a quantum gate based model or inspired based utilization of that for the any of the real use cases. Now I'm shifted to the maritime. I'm inviting to you also can come and work on this. So I'm if anybody are interested on this, my both the problem always I'm open to discuss and work with.
Okay.
Thank you so much.
Okay. Sir, one more thing. You mentioned about some proposal submission is open till January 10th regarding this
15.
optimization.
15. ISC Bangalore, you can just click on
ISC Bangalore.
ISC Bangalore. Yeah, ISC Bangalore, National Quantum Mission Hub. The last date is 15.
Okay. Okay.
Yeah.
Then about this simulator, there are hard gate and C0 gate and swapping. How can we understand about other icons in that section?
You can just click. You can just click, and in the right side, already explanation is will come into the picture. If you click,
Okay.
just drag and drop one gate. Just simple. I make all the operation. You can just pick like Hadmard gate, swap gate, X gate, Y gate, Z gate, and see this what is the matrix. And already the explanation is also there in that particular. You can just click it and see this what exactly what is the function of this. What is the output of this? Bloch sphere is how supposed to the qubit is located, whether it be the northern pole or southern pole or any in between like that. Just
Oh,
try to consider the Bloch sphere is like Earth's surface and think about it in that way, where your qubit
okay.
is supposed to be seated.
Okay.
Okay.
Okay. Okay. Thank you. Thank you, sir.
Good evening, sir.
Yes, yes.
Myself, Sharif, sir. I am research scholar. Actually, I have a small doubt, sir. How to start quantum computing, sir? Give me some suggestion and any books are preferred.
I'm suggesting to read my PhD thesis first. Okay, you can go my Google Scholar, and already I already saw it a public archive first. Second
Yes.
book I mentioned that Nelson and Zhang. If you want to start as a basic quantum computation and quantum information, Nelson and Zhang. If you don't have
Okay.
any idea, please read only chapter 1 to chapter 4. Chapter 1 to chapter 4. That's it. And if
Okay.
you connect with that one, my PhD thesis, the sufficient to start your work from the quantum field.
Okay. Thank you, sir. Thank you.
Please welcome.
Any other questions from
And the simulation is
participants?
basically already QPS, Quantum Program Studio simulator. It's a free way, so you can start your work in the QPS. So any doubts, any questions? If you
Hello,
have
sir.
any questions, please just yes.
Hello.
Yes.
Sir, are these Toffoli, Perez, and Fredkin gates used in quantum computing?
Yeah, you can use that. I'm saying that you can apply. I'm just using the simple gate here. Even you can use the Franklin gate is basically what exactly the control gate is particularly. You can build the hybrid, take the cascading the two control gate. You can build the control with the phase gate. Like many cascading gates should be like, oh, you can apply this. First, you have to check all the operations should be validate your unitary or not. It's not like a randomly I'm just picking any gate. No, I'm not. I know that what exactly gate should be after that and all. You can, if you are trying to start your building the operations, please have to study which gate is supposed to be helping out to your outcome particularly. Okay, you can build a control gate. You can build a control phase gate also. For the cryptography, I'm suggesting to choose control phase gate. For the real actual simulation, I mean simple, you can build a control gate also. You can build a control gate, 2 qubit, 3 qubits also.
Thank you, sir. Thank you.
Any question? Okay.
Thank you so much,
If
sir.
any doubts, please please kindly share to Pawan sir, and he will share, and I will connect. No issue. And you can my number and email ID on my company and eGreen Quanta and QRace. Please just visit. Even I mentioned eGreen Quanta and QRace. Even already many problem statement is there. You can just type in Google eGreen Quanta. I spread it 24, 25 problem statement. Just connect and read that and start your work.
Thank you so much,
Okay.
Dr. Gautam, sir, for such an insightful and thought-provoking session. Thank you so much, sir.
Thank you so much, and good night, everyone. Thank you. Take care.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you.
Thank you, sir.
Thank you.